Kinematics is the study of motion, right? So you have two kind of graphs when you're dealing with kinematics. First things first, you have a displacement. You have a displacement time graph, right? And what does a gradient for a displacement time graph give you? What is the gradient for a displacement time graph give?
Speed.
It gives you speed, right? Because the gradient is the change in y over the change in x. So if the y-axis is displacement, that will change in displacement over the change in time. So the gradient gonna give you speed or velocity, same thing. And what is velocity? What's the units for velocity?
Meters per second.
Right, meters per second. Cool. But in odd maths, it wouldn't write meters per second. We better than that. We write meters minus 1. And if you have a gradient, a positive gradient like this, what does that suggest? If I have a positive gradient, what does that suggest? Does anybody know? Cheyenne, do you know? Not hearing anybody. So if you have a positive gradient, that means you're going at a constant speed. That's what it means. So over here, constant speed.
I can't remember.
Is a constant speed because you're changing displacement with respect to time in a linear manner. So it's a constant speed. Now this over here, if you're not moving, you're staying at the same distance. What does gradient represent?
You're not moving.
You're not moving, you're staying still. So stationary. And this over here is a constant speed, but you're going back to your starting point.
Wait, what did you say when the gradient is negative?
So, right,
You said something with the gradient being negative.
right, so the gradient here is positive. A positive gradient, remember, we're working with vector quantities here. Displacement can either be positive or negative, and velocity is either positive or negative. The positive and negative is indicative of direction, right? So if you have a positive gradient, that means you're going away from your starting point. You understand? So if A was my starting point here, then I move away from A, and then this negative gradient suggests that I'm going back to my starting point. That is what the negative gradient means. It means that you're going in the opposite direction at a constant speed. You understand?
Yep.
Right? So that's what we need to know for displacement time graph. But typically, a velocity time graph has come. So let me look at a velocity time graph. So velocity. Right, so Cheyenne, wait, help me here. So Cheyenne, from a velocity time graph, what do you think you have for the gradient? Cheyenne? Shweta, from a velocity time graph, wait, what does the gradient give you?
Acceleration.
Right, because if you're changing your speed, aren't you accelerating?
Yeah.
Yeah. So this positive gradient here would imply acceleration. What would this imply? If I'm going at the same velocity, what does that imply?
Constant speed, no acceleration.
No acceleration, correct. right? And if you're changing velocity but you're going slower, that means you're what? What's the opposite of acceleration,
Deceleration.
right? Deceleration. So the gradient for a velocity time graph gives you acceleration. And what's the units for acceleration?
MS minus.
Yes, ms minus 2. So I'm sure it's something very unsure. Someone real unsure. I don't ever hear it's unsure.
No, no, I just tired. I just
You say you just tired.
yeah, just tired.
I see, I see. And if I wanted to figure out the distance traveled, Jonathan, if I have a velocity time graph and I want to figure out the distance traveled, how would I figure out the distance traveled? Everybody very quiet this morning and concealing. Anybody can answer. How would I figure out this distance traveled for a velocity time graph?
Area under the graph.
Yep, is the area under the graph. And I know we have some physics students here, so look at this. The units for velocity is meter per second, and the unit for time is second. So imagine you multiply meter per second by second, you'll get meters. So that's the explanation for it. If you want to figure out the distance traveled, you simply find area under the graph. Now, the main formula you need to know is the trapezium one. You need to know the trapezium. Does anybody remember the formula for a trapezium? Area for a trapezium?
Half the sum of the parallel sides by the height.
I think if we get half, half. Yeah. Yeah, it's a half.
Yeah.
Yeah, she's out.
Okay, okay, nice. I apologize. Right? So area of trapezium was a half A plus B by your height. Right, A and B are your parallel sides and H is your perpendicular height. Bam. So that's basically all you need to know for a graph like this. Another thing, you need to know how to find the average speed. They will ask you that as well. So to figure out the average speed, that would be equal to the total distance traveled, so like the whole area under the graph. Total distance traveled all over the what? Average speed is the total distance traveled all over the,
The total time.
right, total time taken. Awesome. Yeah, so that's pretty much it for the graph aspect of kinematics. Does anybody have any doubts or confusion or anything? Let me know now.
Not good.
All right. Cheyenne, Jonathan, me, Hannah here now, yeah. So that's all at all.
Mhm.
So I wouldn't have a choice, and I'm gonna move on to the next aspect of kinematics. This is the graph aspect. Then we look at the integration differentiation aspect. Right? So you need to know what velocity is. Could somebody tell me what velocity is? Velocity is the same thing as what?
Change in displacement with respect to the
Right, so it's speed, right? Basically speed. So he was correct. Velocity is the change in displacement with respect to time. So you'd write the velocity as ds all over dt. Bam. And if I wanted to write acceleration, tell me, what is acceleration? Straight if you're driving your car and I tell you to accelerate, what am I telling you to do? What am I
Change
telling
in velocity with respect to time.
you? Right, that's how fast it changes speed. Right, that's what acceleration is. Oh, shucks. All right, Emma. Emma had to go. She will be missed. Right, so is the change in velocity with respect to time? And how would I write that in terms of differentiation? Straighter.
dv over dt.
Right, like I eating some food there.
Yeah, international.
What are you eating? You're sharing with us?
Oh no, I eat it out just not time.
Wait, that's crazy.
There's some cornbread. I ran out of brownies, so
Oh. So like if I ever have to buy you a gift again, buy brownies.
yes, brownies and chocolate chip cookies.
Noted, noted. I'll buy like the 2 bites brownies. You know what I'm talking about?
Mm.
Like these
Mm-hmm.
small ones. They're
Yeah.
very small, right? So you need to know what velocity is, you need to know what acceleration is. So that brings me to my second point, differentiation and integration. So first scenario. Let's just see you're trying to find distance. Trying find and sure, so let me just say they gave you an equation for velocity. So let me just say they give you, well, they say the velocity is equal to 3t squared plus 2t minus 1. So they give you velocity and they want you to find displacement. How are you going to do that?
You have to integrate.
I would have to integrate. Perfect. Because remember, what is velocity again?
Mm, the displacement over time.
Displacement over time, right? So that's ds over dt. And whenever I integrate, and I would get rid of the dt and thing, and I'll just get s. When I integrate
Yep.
that,
Mm-hmm.
all that ds over dt will vanish because integration does undo differentiation. So let me do that one time. So if I want to find displacement given velocity, you have to integrate. Right. So let us integrate that straight up. So I'm integrating ds over dt. And I'm integrating that with respect to what? What am I integrating that with respect to?
Respect the time.
Perfect. So I'll write dt over here. And I'm integrating 3t squared plus 2t. Okay, so if I integrate ds over dt, what am I going to end up with?
You get s is equal to t cubed plus 2/3 t squared minus 1t.
Yes. And did by chance, did you say plus c? I leave out your plus c.
Sorry.
Oh, yeah. That's sneaky, sneaky plus c, eh? That's sneaky, sneaky plus c.
If I leave, I'm a plus C again before.
If you
So I
forget
won't forget it.
If you figure out plus C, that pressure in the exam, you know.
Yeah.
Real pressure.
Yeah.
Reason I'm saying that is because you get the next part wrong. And if you have any other parts, you get that part wrong as well. Can't figure out plus C. So remember it like this. The C is for a condition. The C is for a condition. So in the question, you will have a condition and you will have to use that condition. They might say when your time is 0, your displacement is also 0. And you might have to plug that in to find for C. You understand what I mean?
Yeah. Mhm.
So think C as your condition that has to be met. So let me just say in this question, they told us that at time is equal to 0, your displacement is equal to 0. Sure, does that make sense? If the time is 0, that means I am move yet. If I didn't
Yeah.
move yet, and my displacement will be 0.
Mm-hmm.
That's a
Yeah.
logical analysis. So
Yeah.
wherever I see S, I will write 0. Wherever I see T, I'll write 0.
C could just be equals to 0.
T will just be equal to 0. We like that, you know? We like that. So then what's my final equation for displacement then?
It'll be the T cube plus the plus T. Oh, just T squared and minus C.
Bam. And you can put plus 0 if you want. You don't have to put that. So if you have velocity and you want to find displacement, you have to integrate. Let's look at a second scenario. I would just say I wanted to find the acceleration and they give me velocity. What I have to do there? First of all, Teresa, acceleration is given by what? What is acceleration given by?
Changing velocity with respect to time, the v over dt.
Oh, and that kind of already spoiling it there. Because if you have velocity and you want to get dv over dt, that means you have to what?
You have to differentiate.
Differentiate. Bam. So let me just say they give you a velocity as give me anything you want, anything that comes to mind.
We could just use back the equation and we could do
All right, say no more. You do that to keep things consistent. Right? So you're gonna differentiate that with respect to what?
with respect to time.
Right? Because time is the unknown there. So differentiate that from what?
You will get 6t plus 2.
Bam. Bam. That's it. And here what? I have a third scenario for you. A third scenario. Let's just say you're trying to find the acceleration given displacement. So, Trace, I remind me, what is acceleration given by? What's acceleration given by?
acceleration is given by dv over dt. But if you have a displacement, you have to differentiate it to get velocity and then differentiate velocity to get acceleration.
That is performance. That's what we're talking about. Right? So you have to do differentiation 2 times.
Twice.
Twice, yes. So it come like finding d squared s over dt squared. If you're talking about it like second differential. But we know
Yeah.
we're not gonna make it so complicated. Just differentiate 2 times. Right? So let me just say the displacement is this over here. I'm gonna use this as well. Everything should work out. Hopefully.
It have a way to differentiate twice in one shot.
If you're real good, it could do it. But I mean, you lose your mark on the steps. Yeah, that's really steps.
Mhm.
Like I could look at this and say this is 6t. That'll be just 2. And this could just be minus, that will cancel off. So I'm end up with 6t plus 2. Yeah, bam, 6t plus 2. But wait, yeah, that's correct. That's correct, dv over dt. But you will lose your marks, huh? You lose your marks so that line not working. And you really had to be good if you're doing that. So Tracer, don't do that. I wouldn't recommend.
Yeah, no, I wouldn't do that.
Because I mean, how hard it is to really differentiate this? You really know hard, right? Like,
Yeah.
no problem. So first things first, we're going to find ds over dt. And ds over dt, that's what?
You get 3t squared plus 2t.
Minus 1.
Yeah, right.
And this stands for what? What's that stand for?
That is velocity.
That's a velocity. Right. And then if I wanted to find my acceleration is given by dv over dt,
dv over dt.
right? So tell me what are we?
It'll be 6t plus 2.
And does that line up with what we got at the first part?
Yep.
Everything work out great. Everything work out great. So this is just basically what I don't know. So made her and Shine. I know it is dealing with diagrams and things, so I'll put a diagram, a kind of flow chart, so you will be able to understand it well. I remember it. So let me just say you want to go from acceleration to velocity. By the way, guys, are really moving fast today. We can't stick because we have a bunch to do. A bunch to do. Acceleration, velocity, displacements. All right, so acceleration is represented by E, velocity is V, displacement is S. Right, acceleration is also represented by dv over dt. The velocity is represented by ds over dt. And your displacement is just S, right? So, Cheyenne, if I have the displacement and I want to get the velocity, what I have to do? Yeah, I'm hearing Cheyenne. Anybody tell me. If I have the displacement and I want to get velocity, what I have to do? Rita, if I have displacement and I want to get velocity, what I do?
You differentiate ds over dt.
Right? And if I have velocity and I want to get acceleration, I have to do that. Bam. Color. And if I wanted to go from acceleration to velocity, I would have to integrate the acceleration with respect to time. And if I want to go from velocity to displacement, I would have to integrate a velocity respect to time. Right, so this is a little chart or like a little. Okay, so the next thing you need to know, you need to be acquainted with a couple of terms when dealing with kinematics. Put this in pink. All right.
And for the exam, number one, if codomain, that's your range. No, that's not your range. That's your like you have one circle, a domain, and them numbers plot into the next circle for the function. That is a codomain.
Yes, yeah, codomain. So
I
let me
think
yeah.
the exam relatively easy. It's worded so weird, like you gotta sit down and read.
So the values for x as a domain and the values for y equal are the codomain, and it's also called the range. Yeah. So the x values we map it onto the y. When you map it onto the y, you get your values for the codomain by range. You understand me, huh? And as you
Yeah.
was talking about, and you was talking
Yeah.
about that? Yeah, nice. Okay. So let's move on. Show me what's going on. So let's look at some important terms you need to be acquainted with. So, Meta, if you see it, if you see them say rest, at rest, what does at rest mean? What does that
That your velocity is 0.
if velocity is 0? Yes.
Yeah.
And if they say start at rest, what we know for that?
0.
Start at summer that again. If they say start at rest,
Is start at 0.
the time is 0. The time is 0 and the velocity is
0.
right, but at rest does not always mean the time is 0, right? I could have traveled for like an hour and then go at rest. So make no sign of that. Right, the other one, sometimes you can see them talk about instantaneous rest. Instantaneous rest. And that too, that just means the velocity is 0. That's what it means. So everybody okay so far? I'm gonna if I understand everything. Jonathan and Shine, and I hear you at all. I don't know if I'll want me to run through back anything. I don't mind.
No, I understand.
Shine, how come you're so quiet? You get rest last night?
Yeah.
I had to hear, I had to hear. I had to go, I had to go. Can't be quiet. Right? So let me do some questions one time. I'll be at it. All right, so let me do 2012 question 8. That's a good place to start off. Right, so who wants to help me with 2012 question 8? Yeah, any volunteers? I need somebody, somebody gotta help me. I don't know what to do.
I'll
Anybody?
help you, sir.
I need some serious help here. Hmm.
Okay.
Yeah, come on. Twitter.
Yeah. Mm-hmm.
You know, I don't want to do the. So I'll do. I think I could do three questions. I think I could do three questions, right? Before I move on to the next topic, which is
Mm-hmm.
trigs. So, Twitter, you help me with one. Who want to help me with the other question I'll be doing? It's only have four people.
Cheyenne. I'm Cheyenne. Help me.
Cheyenne, Cheyenne, you go help me with the next question, next one. And Jonathan or Meadha, which one all you want to help me with the last question for kinematics?
Nida.
Meadha, real go ahead. Although they're probably like dead tired. Like, ooh. So we volunteer Meadha. She had to do it then. So Shweta, give this question already.
A car starting from rest at point A moves along a straight line, reaching a velocity of 24 meters per second by a constant acceleration of 6 meters per second squared. The car maintains this velocity of 24 meters per second for 5 seconds and is then brought to rest again by a constant acceleration of 3 meters per second squared.
Hmm. So give the question. Give the questions already. Part one.
Using the graph sheet provided, draw a velocity time graph to illustrate the motion of the car.
So the question I gave you all in the mock test is extremely similar to this question. It's very similar to this one. Shweta, I think you'll be able to manage with this question.
Um, I could try.
Try asking.
Yeah.
So then we just analyze the question and pick out the information. So they say it's starting from rest. If it's starting from rest, what things do we know? If it starts at rest.
If it starts at rest, your velocity is 0 and your time will be 0 at first.
Okay. And they're saying it moves along a straight line, reaching a velocity of 24 meters per second. And a constant acceleration of 6 ms minus 2.
Mm,
So let me do a rough sketch here. So first of all, what kind of graph is this, Shweta? What kind of graph is this?
velocity time.
And in a velocity time graph, the gradient does give you the
Acceleration.
acceleration. Yes, give you the acceleration. So they say it's starting from rest and it moves along a straight line, reaching a velocity of 24 meters per second by a constant acceleration of 6 ms minus 2. You notice they talk about constant acceleration. So it reached a speed at 24 and the car was accelerating at a constant acceleration. So there's a positive gradient or a negative gradient.
Positive.
Positive. So this is what's gonna happen. The car starting from 0, 0, right? Because your time is 0, your velocity is 0. I wonder if that makes sense.
Mm-hmm.
And it accelerated until it reached a velocity of what?
24. And it could be going in a straight line for 5 seconds.
Right? Yes. And we know that the acceleration over here, what's the acceleration over here?
6 meters per second squared.
And do we know what the time is?
You mean the 5 seconds?
Nah, that 5 seconds had to deal with the other part of the journey for the car. Let me explain. So
Mhm.
they're saying the car starting from rest and it accelerates uniformly until it reaches 24 meters per second. They didn't give us anything about time there. anything about time.
No.
Nothing about time, right? Nothing
You
about
have to
time.
use a formula.
No. Yeah, we fine. That is our formula. It don't have any formula you need to remember in specific. Like it's our V is equal to U plus AT, and
Yeah, I was going to ask if we use that.
you don't have to remember them formulas. As you get think about kinematics and maths and art maths, you don't have to remember them things. So we're gonna calculate it using everything we know so far. At the end of the question, right? In this part over here, they just want us to draw a velocity time graph. So we sketch it here. So do we know what the time is? Yes or no?
No.
No, we don't know what the time is. So we want to call the time then.
T, I guess. The
All right.
T1 or something like that.
Call it T1, right? And then it maintains its constant velocity of 24 meters per second for 5 seconds, right? So then this time over here, if it's 5 more than T1, this
T1 plus 5.
right. And what next?
Is brought to rest by a constant acceleration of -3.
Mhm. It's brought
So
to-
it's going downwards now.
yeah. So it can maintain this, and it then brought to rest by a constant. So going down, and then going down at a rate of 3 ms minus 2. That's why going down by, and it's eventually at rest here. And we don't know what this time is here, right? We don't know what this time is. Let's call this T2.
Yeah.
All right. So determine the total distance traveled by the car. These are tough questions. Okay. Let's see what we could figure out, right? If we have the times, like at least T1, it will be helpful there. So you know that it's starting from rest, it moves along a straight line, and it has a constant acceleration of 6 ms minus 2. All right. So straight up, if we need to figure out time, let me show you how we could do it. So in a velocity time graph, what does the gradient give us? It gives us acceleration, right? And what area under the graph give us?
Distance.
But then, they didn't give us any distances.
No.
It's a different kind of question. Actually, how to use the formulas then?
Oh, thank God.
Actually, how to use the formulas.
Thank God.
There was a change in the syllabus at some point, so presume they had only formulas for this question then. So let me see if we can use the formulas, right? So at this, we're looking at the first part of the journey. So we have the velocity, we have the acceleration, we have the time, we don't have the time. So what equation have velocity, the initial velocity, time and thing in it? What formula do you know have that in it?
V equals U plus AT.
Yeah. V is equal to U plus AT. But I'll show you guys the test I set. You didn't have to use any of these formulas. Right. So what's the velocity you reached?
24 meters per second.
What was the initial velocity?
0.
Right? And what was the acceleration?
6.
6. And we don't know what the time is, right? So I end up with 24 is equal to 6t. So then t would be equal to what?
24 divided by 6.
Right? Which is 4.
4.
So we had to use the formula there. I'm gonna just get more space. Need some space. So we do a more modern question next rounds. It's like a physics question, it's like exactly like a physics question. Or if you get this in all your physics exam. Like no joke.
Two birds with one stone, practicing at maths and physics.
Yes. Okay. Yeah. The equation thing, you just get some trouble. Like the maths. Copy. Let's see if we go paste. Okay, paste, nice. Okay, so there will be detailed calculation here. So v is equal to u plus at. You have to use that. We don't have a choice here in this question. So the velocity we reached was 24. The initial velocity was 0 because we started at rest. We know that the acceleration is 6. And we're trying to find the time. We're trying to find for t1. So you'll end up with 24 is equal to 6t1. You divide both sides by 6. So you get t1 to be equal to 4 seconds. So then we actually draw a graph now. So that'll be 24 right here. We got 4 there. Right? And as the first part of the journey. So Shweta, if we know the time t1 is actually 4, what would be what would be the other time? The 5 plus the t1 time. What would that time?
It'll be the 5 plus 1, so you have 9.
Yep, it would be 9. And on the second part of the journey, did you accelerate?
I think no, it's decelerate.
Nah. The second part of the journey actually maintained a constant
Oh,
velocity. A constant velocity of 24 meters per second for 5 seconds. Yeah. So that'll be right here. Yeah. And then we decelerated. We decelerated at a rate of minus 3 ms minus 2. Yeah. So can we use our same formula? Tell me straight up. You think we could use our same formula? V is equal to u plus at? To figure out the time at which it stopped. Tell me if you think we could use our same formula. Think about it carefully. Do we know what the initial velocity is?
yeah,
What's the initial velocity in this case?
it's 0.
Nah, that's the final velocity because remember, you're decelerating until you end up at rest.
Your initial velocity will be the 24.
Right? Initial will be 24. The final velocity will be
The 0.
0. And we're trying to think, do we know what the time is?
No,
No, we don't know what the time is. Do we know the acceleration or the deceleration?
minus 3.
Or we wouldn't write the minus 3. Wouldn't write the minus 3.
Okay.
Because you're going to put negative time and all kind of thing. We just wouldn't write the negative 3. So v is equal to u plus at. Tell me what to write.
It will be 0 is equal to 24 plus 3t. I think we would end up with a negative if we turn across the 24.
We will end up with a negative, yeah. So best we
So
just
you
take,
have to put the minus 3.
best I do that, yeah? Best I do that. Because the only way you're gonna put a positive answer is if you leave the negative there. Yeah. So you're gonna put minus 3t is equal to minus 24. So then t would be equal to what?
8.
So let me ask that question. From this point over here, when you start to decelerate, how much time after it take before you actually stop?
It would be 8 plus the 9,
Right? Yeah, and that'll be what?
17.
Yeah, that'll be 17. Right here. Oh God. Right. So I guess be wary of the formulas, guys. I really don't know if it come like this year, but I highly doubt that because they did change up the syllabus. So Shrita, if I wanted, could I easily find the distance travel?
Yeah, and I could find the area.
Yeah. Because we have all the dimensions we need.
Mhm.
Let me check out the other part of the question now. So guys, if they do not tell you what the distance travel is for any parts of the journeys, you'll have to use v is equal to u plus at. So just look out for the final velocity, the initial velocity, acceleration, and the time. V is equal to u plus at. In the second part, they want us to determine the total distance traveled by the car. That shouldn't be an issue at all. So, Mira, what kind of shape the whole thing looking like? What kind of shape this looking like? A trapezium. So you think you could tell me this measurement over here? What would this measurement be?
Oh,
You said all before?
yeah.
Nah, that wouldn't be 4.
No, no,
It'd be 5. Yep, that would be 5. And what would the other lengths be for the bottom?
um, 17.
17. And what would the perpendicular height be?
Will be 24.
Right. And what's the formula for area of a trapezium?
A plus B by perpendicular.
Yes. So that'll be equal to,
I got 264.
you get 464,
264.
264, right? And could somebody just confirm that with the calculator? By the way, guys, make your wish. 11:11. Yeah, I got 264. And what would the units for that be made of? Since area gives you distance traveled, what would we measure distance in?
Measure distance and meter.
Yes. look at the units for velocity, it was meters per second. So the unit it was measuring distance in was in meters, right? But Shweta, that is not the end of our worries. They still have a lot more.
Sadly.
Yeah. Right. So I wait to read part 2, sorry, part 3. Oh wait, give me a second, guys. Okay, I'm back. So Shweta, read part 3.
A second car moving at a constant velocity of 32 meters per second drives past point E 3 seconds after the first car left point E. What? Wait,
That a bit confusing.
okay. A second car moving at a constant velocity of 32 meters per second drives past point E 3 seconds after the first car left point. Oh, okay. 3 seconds after the first. So the second car, 3 seconds behind car A.
Wait, sir.
Okay.
A second car moving at a constant velocity of 32 meters per second drives past point E. So the first car, it started from rest at point E. So truth be told, this over here is point E. This over here is point E. And it's saying here that the second car drives past point A 3 seconds after the first car left point A. So yes, it's 3 seconds behind the other car because it left 3 seconds after the first car left point A. So the other car leave point A already, but this one leaving 3 seconds after that. Yeah. Right, so continue.
Calculate the length of time after the first car started that this second car meets it. Calculate the length of time after the first car started that the second car meets it.
These Olaya brutal. Yeah. These Olayas.
The English, not Englishin.
Read this entire question and start a new one now.
You're gonna throw away this question. Cheyenne, what do you think?
Yeah,
I
you should.
wonder why this was the first paper that ever come out, if you could tell.
Well, okay, I'll do our next question. Probably against the question so bad. Um, let me look,
This paper is recently changed the syllabus.
let me go for very recent here. The syllabus changed in 2021. So we could try 2021. Right?
Okay. It's so much shorter. Oh my god.
Wait again, a call from Desron. Let me hear what you say.
Oh
Yeah.
Lord.
Hey Cheyenne. Cheyenne, guess
Oi.
exactly what. So last night, I do something with Desron and that's the exact same thing that comes. And it's
Very
the exact same thing. I do books on the pendulum. Exact same thing that eh,
very hope that happens so it.
let me hope I predict all the paper good.
Mm-hmm.
Books. I predict the paper 3. I hope I can predict the paper 2.
What you predicting? You think paper two? Somehow
I think
predict.
I
We
think
don't predict Bob, you predict Des wrong thing. What you gonna predict again?
I have a feeling that this year they wouldn't test so much on probability. I feel like the main emphasis gonna really be differentiation, integration, and trigonometry. I feel like you got real hard to know trigonometry this year. I feel so. Physics, I feel like thermodynamics are all gonna come. That's just my feeling. I feel like you gotta know the Boyle's law, Charles' law, pressure law. Feel like you gotta to know latent heat of vaporization, them kind of thing. I don't know, but I'll make a predicted paper for physics too. Right? So let me do 2021. So Shweta, let me do 2021. This one should be really easy. So read 2021.
Which
Uh,
one?
uh,
4, 5.
We're doing both. Both of them is kinematics. So 2021 question 4.
A motorist starts from point X and travels 60 meters due north to point Y at a constant speed of 4 meters per second. He stays at point Y for 25 seconds and then travels at a constant speed of 10 seconds for 100 meters due south to point Z. Calculate the average speed for the whole journey and average velocity for the whole journey.
Okay, this question. Let me just do a sketch of the graph, right?
Mhm.
You know what kind of graph?
Velocity time.
You know what velocity?
Wait. Oh, I do this question, but I didn't use it in like a graph kind of method. I do a different kind of sketch. Yes.
Oh, wait. It's not velocity time. Let me read back the question one more time. A motorist starts from a point X and travels 60 meters due north to a point Y at a constant speed of 4 meters per second. He stays at Y for 25 seconds and then travels at a constant speed of 10 meters per second for 100 meters. Notice this at constant speed. If they're talking about constant speed, they're talking about a distance time graph here already. It's a distance time graph. Did you use a distance time graph?
I didn't use any graph.
Okay, well, I still go and do a sketch of the graph. I still go do a sketch of the graph. I see you drawing something there.
Yeah, this is how this is a diagram I use to understand what's going on.
So a motorist starts from a point X and travels 60 meters due north to a point Y. At a constant speed of 4 meters per second, he stays at Y for 25 seconds and then travels at a constant speed of 10 meters per second for 100 meters due south to a point Z. Okay, I understand your diagram there. So he's starting from X and travels 60 meters due north to a point Y. So he going 60 meters to Y, right? And he stays at Y for 25 seconds and then travels at a constant speed for 100 meters to a point Z. Right? Let me interpret that in a diagram. So straighter, he's starting off from point X. If he starts at point X, what is his distance and what is his time?
We have no distance and no time yet.
You have no distance and no time. Right? So he's starting at 0, 0. And it's saying that he travels 60 meters due north. So what will the distance be there? So he's starting from X and he travels a distance of,
60
right,
meters.
at a constant speed of 4 meters per second. So then,
As the timer would be
so he traveled, so the distance there is 60 meters
divided by the 4.
and the speed is equal to 4. So speed is equal to distance over time. So the distance was 60. So you gotta make time the subject of the formula. S is equal to d over t.
Time could be
How would time be?
distance over the speed.
Yes. And your distance is 60 and your speed is 4. So what would the time be then?
15 seconds.
Right. Right. And he stays at Y. So this is point X, this is Y. And what does he do next? So he stays at Y for?
For 25 seconds.
If he's staying at Y for 25 seconds, so is he moving? Nah, he's not moving. So we have a flat gradient like this. And what was 25 plus 15?
40.
40. Yeah. And what next? What next is he doing?
He then travels at a constant speed of 10 meters per second for 100 meters due south.
Okay, so remember what I tell you about displacement and velocity and thing? Those are
Mhm.
those are vector quantities. Those are vector quantities, meaning that they have direction. So if 60 meters due north at point Y was a positive gradient, that's because he was moving north. What kind of gradient do you think
Negative.
be a negative gradient? How do negative gradients look?
Your graph goes downward.
Go downwards. So he travels at a constant speed of 10 meters per second for 100 meters due north. So we have his speed here. What is his speed?
10 meters per second.
And what was the distance?
100.
Okay.
So your time would be 10 seconds. So it'll be at 50 seconds he at point Z.
Yes. Right, and this point over here, this could be easy. So let me know if you understand the graph.
Mhm.
So, like I said, this displacement, velocity, all of those are vector quantities that have direction. So if you're starting at X and you're traveling 60 meters due north, that's a positive gradient. When you reach Y, you're staying there, so you're not moving, your displacement is constant, it's just 0, right? And he stayed there for 25 seconds. So that's how we got the 40. 15 plus 25 is 40. And then he traveled at a constant speed of 10 meters per second for 100 meters due south. So meter, if he's going south, is he going in the same direction, north, or is he going in the opposite direction? Opposite direction. So my gradient will be negative. And meter, they said he was traveling at a constant speed of 10, and it was 100 meters was the distance. So then I have my speed, I have my distance, I just had to find time. You understand how I find time?
Yeah.
Right. So,
You can
Mira,
explain the graph real fast.
yeah, we're explaining just so.
Yeah, we are sending out.
So, Mira, wait to read back the question. Read back the question. Fast, fast. Fast, fast.
A motorist starts from a point X and travels 60 meters due north to a point Y at constant speed of 4 meters per second.
All right,
He
stop there.
stays at Y.
Stop there. So, they said the motorist started from rest. If he starts from rest, then that is 0, 0. And they're saying he traveled
No. Didn't say he starts from Y.
Didn't see that? Well, they say that he starts from a point X, right? So I'm going to call this point here X. He starts from a point X and he travels how much distance? How much distance does he travel from X?
60 meters due north.
Right. Travels 60 meters due north. You understand why I draw the line like that?
Yeah.
Okay. And after he reached point Y, what does he do?
He travels at a constant speed of 4 meters per second.
You know, that was his speed to reach point Y. That was his speed to reach point Y. So he had to travel 60 meters and he was traveling 60 meters at a speed of 4 meters per second. So let's erase this. So Mira, he's starting from X and he had to go to Y. And that is 60 meters. The distance is 60 meters. And what is his speed to travel to point Y then? What is his speed?
You could repeat that?
What is his speed? If he has to go from X to Y, what is his speed?
It would be 60 over the 4.
Nah, they gave you the speed. So he travels 60 meters due north to a point Y, and they say he traveled at a constant speed of 4 meters per second. So made what's the formula for speed again? Speed is equal to what?
It is different over time.
So what do we have here? Tell me two things we have.
You have a speed and you have a distance.
I have my speed and I have my distance, so I'm trying to find my what?
Yeah, time.
Trying to find my time. So I have to make time the subject of the formula. So time, that would be equal to d over s. So what is the distance from X to Y? Tell me, what's the distance from X to Y?
60 meters,
60 meters. And what is the speed I'm traveling at?
4 meters per second.
So how long it take it to reach Y from X?
15 seconds.
Right. So let me know if you understand how I get this part of the graph.
Yeah.
All right. And next part. Read this one.
That's why for 25 seconds and then travels at a constant speed of 10 meters per second for 100 meters due south at point Z.
All right. So when he reaches Y, he stays there for how much time? How long
It
is
is a constant speed.
wait, sir? Read back this one. Just read back this specific part.
60 meters due north at point Y of 4 meters per second. He stayed at Y for 25 seconds.
Right. So he's staying at Y for 25 seconds. So that means the gradient is it's just a horizontal line because he's staying there. Right? You notice he not moving, so he not changing his distance. You understand? Just a flat line because he's staying there. So you have to add 25 to 15 and you get 40. Right?
Yeah.
And what does he do after he stays there for 25 seconds?
He then travels at a constant speed of 10 meters per second for 100 meters due south to a point Z.
Okay. Now, Meta, at the start, X to Y, that's north. And now we going from Y to Z, which is south. So that's the opposite direction. Meaning that the gradient will change direction. In a displacement time graph, this is what it is, a displacement time graph. It can either be positive or negative. Now, in this question, north meant positive and south meant negative. The direction changes a gradient. So north was a positive gradient, south is the opposite, so that's a negative gradient. Remember, displacement is a vector quantity. It has direction. So you just have to be careful of that. So let me know if you understand what I do over here. So,
Yeah.
and here what? He traveled at a speed of what? To go from Y to Z, he traveled at a speed of what?
Was at a speed of 10 meters per second.
And how far was Z from Y?
With 100 meters due south to a point Y.
Right, it's 100 meters. So we know the speed and we know the distance. So can we calculate the time?
Yeah.
Yeah, we can do that. Right, so again, if we want to find time, we could use this formula here. Time is equal to this displacement over your speed. Distance over your speed. So tell me what to write me now. What is your distance?
So your distance will be 100 meters per
Yeah. And that will give you a time of
10 seconds.
10 seconds. right? So then I add the 40 to the 10 and that's 50. And because I went in an opposite direction, my gradient is negative. So that explains the graph there.
Or 100 meters, or if it just count 100 meters, like down from 60,
Wait, sir?
and you reach negative 40,
Yes.
the
Yeah,
graph.
that's correct. So is basically what Shweta drew over here in this diagram here. So
You could you could explain it, I don't know.
Shweta,
Huh?
mean how way to re-explain your diagram.
Okay. So the person at point X and they're going to point Y, but point Y is a north. So the 60 meters from X to Y. And from Y, they want to come down to Z, but Z is south. So from point Y, they're coming back downward to Z, and the distance is 100 meters from point Y to Z. That makes sense.
I go explain it. I'll try to explain your method. Mira, we need to hear for this. Mira? So Mira, you're starting from X and you're traveling to Y. Now it's due north, so that's why straight I draw the arrow going up because it's due north. And it's 60 meters. You understand?
Yeah.
And then from Y, you go into Z. And Z is due south of Y. So that's why she drew the arrow down. And from Y, Z is 100 meters. So that's why she put the 100 meters there. Yeah. So meter, how much distance you really travel then? How much distance you really travel?
100.
Where is it?
Um, 100,
You say 100 meters?
160 meters.
Yes, 160 meters. And how much time did it take you to travel that 160 meters?
50 seconds.
Is it 30 seconds or 50?
50.
50. So if you want to figure out the average speed for the whole journey, that'll just be your total distance over your total time. So the answer for the first one will be 160. Wait, sir?
Can you recite it? It is so bad.
I wouldn't say like this hard. The modern questions are a bit easier in my opinion. We will do some questions and you can see for yourself. So Mira, you go help me with the next question if you want. So here what you go do 2022 and Cheyenne, you go do 2023 with me.
Okay.
So what is 160 divided by 50?
Yeah, 2.2.
They get 3.2.
3.2.
And what's the units for that?
2.2 meters per second.
Yeah. Now,
No, just meters per second.
yes. Now I have a catch here with the average velocity here, guys. There's a catch there. Someone they might say, well, someone they might write back 3.2, but I assure you that's wrong. When we're talking about speed, speed is a vector or a scalar quantity. Somebody tell me, speed is a vector or a scalar? Anybody tell me? What is speed? Physics people. Somebody tell me. Speed is a vector or a scalar?
Yeah.
It's a scalar. So Cheyenne, does speed have direction?
No.
No, we just care about you go from one point to the other point. So in the first part, we didn't care about the direction. You add 160. But in the next part, you're gonna pay attention to the direction. So let me show you what I mean. So Cheyenne, if you go in north, that's positive or negative? If you go in north, your
Positive.
displacement is positive. And if you go in south now, is your displacement positive?
Negative.
Negative.
No.
So look at what you had to do if you had to find average velocity here. It's actually 60 minus 100 all over 50. And what would that be equal to?
Then minus 4/5.
Minus 4/5, right? And what would the units for that be?
Velocity.
Wait, so
What units of velocity is it?
velocity and speed is the same units. It's the same
Oh,
units.
right. MS minus 1.
ms minus 1. Right. Now, Shweta, I'll be very honest. Your diagram, much better than the graph. Honestly, it's much better. I prefer that 100%. So I will put that diagram. I'll leave this diagram because it's slightly the mathematical proper way to do it. But your diagram is a very nice way to do it. That makes a lot of sense in the simplest way possible. So I will.
Is it the graph thing? Take a picture so I can draw it.
What the graph over here? All right.
Let's take a. Okay, got it.
But if they ask you to plot the graph, you need to know how to do. But they don't ask you that here. Just do a little sketch there. So I'm going to.
Later on, you would find the total distance. For how you would find the speed, the average speed.
You're confused by the average speed?
No, like if you use Shweta diagram, you would get the total distance, right? For
Mhm.
how you would get the total time.
Oh, you're just reading off the the x-axis, that's all. That's all.
No, I mean like if you use Shweta diagram and you do plot a graph.
That's what you're asking. Well,
Yeah.
you would have to find the times individually and add them up. So you see how I find the time over here? You would have to add up those times. So it would be a little harder to get the
I
time from that.
just like how you had worked it here with the 60 over 4 and the 100 over 10 is the same thing I do. Then I get the 15 and the 10, and then I add it to the 25 seconds.
All right, well, that's not much harder. That's not much harder. So I'm going to explain the question according to Shweta. And Shweta, I'll big you up over here. I'll big up Shweta. Big up Shweta. All right. So meet her. A motorist starts from point X. So the displacement will be in reference to point X, right? So you're starting from X and you go into Y. Now Y is due north. So meet her. From X, Y is how much distance away? How much distance? X to Y. What's the distance from X to Y?
60 meters.
Right, that's 60 meters. And to go from X to Y, you travel at what speed?
Travel at 4 meters per second.
Right. So what is the time it take it to reach there then? That will be 60 over 4.
Mhm.
So tell me what that'll be.
15.
And when you reach y, how long you stay by y for?
Stay by y 25 seconds.
Right. Right? So you just take that into consideration. And now from y, what you do next?
From y, when I stay 25 seconds, it travel at a constant speed of 10 meters per second from 100 meters. No, do so.
Anybody hearing me, huh?
Hello.
You sound like I like you're underwater. I don't like if you're underwater.
I'm feeling like I'm underwater.
So so let me just say you leave y. What are you doing next when you leave y?
When you leave y, you then travel at a constant speed for 10 meters per second, 100 meters.
So when you leave y, you're going in one direction, north or south.
So,
And how far you travel?
100 meters.
Right. So from y you go in 100 meters. Yeah. And this is z. And what's the time it take it to go there? It was traveling at a speed of 10 meters per second. Okay.
Mhm.
That will be 100 over 10, which is just 10. So I mean, if you want, you could just add up your times, add up your distances, and just divide it. So that would not be hard at all. So, mate, I wonder if you understand the speed part.
Yeah.
Now, the average velocity. I need to make sure you understand this. I don't want to lose enough 4 marks all you could possibly get. So, meter velocity, is it a vector quantity or a scalar quantity?
Scale up a vector.
A vector. So it has what then? Other than size, what does it have?
It has magnitude and direction.
Right? So magnitude is the same thing for size. So the main thing we're looking at is direction. So if you're going from x to y, that's positive 60. And if yes, wait, I don't mean positive 60. Let me check something. Yeah, if you're going from x to y, you travel that displacement itself is positive 60. Yes, I'm saying the correct thing. Right? And meter. If we go in the opposite direction, what is our displacement then? So x to y, that's positive 60. But if you go in the opposite direction, what is your
It would be
displacement?
negative.
Negative 100. And what's the time it take you to do everything?
50 seconds.
50 seconds. So this is how I did answer the last question. I wanted to figure out the average velocity. So the average velocity, that would be your two displacements together. So my first displacement, I travel north from x, so that's 60 plus 60. And then I travel 100 down, which is minus 100. And to do all of that, it takes me 50 seconds. So 60 minus 100, that'll be minus 40 over 50 minus 4/5 meters per second. Yeah. Straighter. I mean, if you understand.
Wow.
Me.
60 minus 100 over 50.
Yes, because velocity is a vector quantity. You have to take into consideration the direction. So if I'm going north, that's positive. And then the next part of my journey, I went south, which would have been negative. I mean, if you understand that.
Okay.
In the first part, speed, average speed. Speed is a scalar quantity. We don't care about direction. We just care about the distance. So that should be 160 over 50. But in second part, we care about the direction. So that'll be 60 minus 100 over 50. Cheyenne, I'm gonna if you want to explain it back again.
No, I understand now.
All right. So Cheyenne, if instead of going south, you had travel north again, would you have had minus or add?
Add.
Correct, because they're going in the same direction north.
Yes.
So that was a okay-ish question. Let me try 2021 question 5D now. These are the easiest kind of easier kind of questions. The questions with
Which
integration.
one? 2021, 2022.
Oh, we're still on 2021. Still on 2021. Still on 2020. So here what, right? This is the format. You will get a question, a graph question, and then you'll get a question where you'll have to integrate or differentiate. That's the format. A kinematics question is probably like 20 marks altogether. 14 to 20 marks. So we're looking to get our marks. So, straight out, let me do 2021 question 5C. So give that a read for me.
A particle starting from rest travels in a straight line with an acceleration a given by a equals to t squared, where t is the time in seconds. Determine the velocity of the particle of time t.
Okay, so notice they gave us acceleration. Acceleration is the same thing as what? What gives acceleration?
dv over dt.
Right? dv over dt. Nice. And if I want to get velocity from dv over dt, what do I do?
You have to integrate.
Right? Because I will be going backwards. Lovely. And whenever you integrate, you're gonna end up with what? Don't forget them. Don't forget it. Whenever you integrate,
Plus c.
plus c. And you have to use a condition to find the plus c. So let me look for the condition, right? They said the particle starts from rest. If the particle starts from rest, what's the condition there? Tell me what the condition is.
v equals to 0.
When the time is equal to
0.
right. So that's the given condition there. So when you start at rest, that means when time is 0, your velocity is 0. So let's figure out part 1. So we have to integrate dv dt. Integral of dv over dt, and we integrate them with respect to what?
Time.
Right? And you would have to integrate t squared. Right? So when I integrate dv over dt, what would I end up with?
2. Wait, hold on. No.
Left hand side. If I integrate dv over dt,
A third t cube plus c.
wait, here was it, eh? If I so forget about this side over here. If I integrate dv over dt, what would that give me?
v.
Right? So v will be equal to the integral of that. So tell me, if I integrate t squared, what will be?
A qt. A third t cube.
Right. If I get in somebody, you know, again somebody
Plus c.
plus c. And what was the condition?
When v equals to 0 and t equals to 0.
So anywhere I see v, I'm gonna write 0. Anywhere I see t, I'm gonna write 0. So c is equal to what really?
0.
C is equal to 0. So then what's my final equation for velocity?
v equals to a third t cube.
Right. And so we figure out part one. We're going to figure out in part two.
The displacement between t equals to 0 and t equals to 2.
Cheyenne, I want you to pay special attention to this. The big hint here is that you have an upper limit and a lower limit. What is our upper and lower limit, guys? What's up?
Definite integrals.
Yes, definite integrals. And another thing, if they just now make you find velocity, velocity can be written as what?
Wait, that's where I wanted from.
Okay, so I have t cube over 3.
Yeah.
T cube over 3, that's the same thing as a third multiplied by t cube.
Okay.
Because watch, 1 by t cube is t cube, 3 by 1 is 3.
Okay.
Right? So, Cheyenne, while you're talking, Selma, what is another way I could write velocity? Velocity is the same thing as what? In terms of differentiation. What is velocity?
Speed.
Now, velocity is not speed. I'm talking about like the differentiation notation. So like the what over the what. Velocity.
dv over dt.
Nah. Velocity is a change in displacement over the change in time. So that is ds over dt. So Cheyenne, if velocity is ds over dt, right? And it's in the second part, I want to find the displacement. Or what I have to do with ds over dt? Find it. See if we can tell. So
Integrated.
right, because I want to get rid of the whole differentiation there and find for s. And the other big hint is you have a lower limit and an upper limit. I mean, say integrate. So straight, I'll finish up the question there. You tell me what to write. I'm what to write straight up. I hear it straight up.
So you can write s is equal to the integral of v dt.
Yeah, you could write that. So this is how I'm gonna write it. Something very similar to what we just now pulled out. So integral of ds over dt. Now ds over dt, that is velocity.
Mhm.
That'll be equal to the integral of we just now find. We integrated velocity, right?
Yeah.
And velocity is equal to what? What's velocity?
1 to, well, t cube over 3.
13 over 3.
No, t cube over 3. If you leave the velocity right there, so get a mark.
Wait, sir?
If you leave the velocity like t cube over 3, you still get a mark.
Yeah,
And
you're
the
still
same.
getting marks. Still getting marks. You're still getting marks. They can already take away a mark for that.
Here.
So, Cheyenne, when I integrate ds over dt, what do I end up with?
S.
S. And if I integrate t cube over 3, what are we? So when you integrate, you add 1 to the power, and then you divide by the new power.
Okay, so t4 over
So
4.
nah, you had 3 in the denominator already.
Oh, t4 over 12.
Yeah, 2 to the power 4 over 12, right? And don't forget the plus c.
Yeah.
Don't forget the plus c. Something else. Sean, if you, well, wait, never mind, you wouldn't have a plus C there. You wouldn't have a plus C. You know why you wouldn't have a plus C?
Because you have an upper and lower limit.
Right, so we had to apply the upper and lower limits. So the 2 would go over here and the 0 would go over here. So we have to work out that now. So from a square brackets, upper limit is that, lower limit is that. Wait again, for come on a second. Real busy today, one. All right. So, Cheyenne, since it's a definite integral, you have to apply your upper limit and your lower limit. So let me separate it into cases now. So anywhere I see t, I'm gonna write 2. So that'll be 2 to the power 4 all over 12. Right? And then I'm gonna minus that from 0 to the power 4 over 12. That's all definite integration as well. So whatever the upper limit is, I plug it in and I minus it from whatever the lower limit is.
Oh, okay.
Yeah. And you just use definite integration to find area as well. So anytime they ask you for area, they're talking about this. That's what they're talking about. Do definite integration. So what is 2 to the power 4 over 12?
That's 4/3.
You get 6 over 3?
4
4 over 3, okay. And what would the displacement be? What would the units for that be?
meters.
Yep. Right, so the differentiation and integration part is the easiest part. You just see diagrams. That's the tricky part. Right? So we made higher rates up. One quick question for 2022.
Yeah.
I don't think 2022 you have to draw a diagram. I don't think so.
The particle moves in a straight line so that 3 seconds after passing through a fixed point O, its acceleration A is given by A equals 3t minus 1 meters per second squared. When t equals 2, the particle has a velocity v of 4 meters per second and a displacement of 6 from O. Determine the velocity when t equals to 4.
Okay. So meter. It's a particle moving in a straight line. So t seconds after passing through a fixed point O, its acceleration, they give you acceleration. Right? They're telling you that the acceleration is equal to 3t minus 1 ms minus 2. And when t is equal to 2, the particle has a velocity of 4 meters per second. So do you have a condition there?
Yeah.
Right. So I'm going to try on the condition. When time is equal to 2, the velocity is 4 meters per second. And they give you the acceleration. Acceleration is 3t minus 1. First things first, meter. I want to find velocity. Right?
Yeah,
Velocity.
integrate acceleration.
Right. I would have to integrate acceleration. Now, acceleration is the same thing as dv over dt. And I would have to integrate that. So I'm gonna write integral of dv over dt. I integrate with respect to time here. dt minus 1. All right, so Mita, if I integrate dv over dt, what would I get?
You get 3t squared on 2 minus t.
You're correct, but that's not what I'm asking. I'm asking it on the left-hand side,
Oh, you get your velocity.
right? On the right-hand side, I get 3t squared all over 2 minus t.
Minus t
If you're getting somebody,
plus c.
right? And what was the condition?
Your condition is when t equals to 2, your velocity will be equal to 4.
Right, so I'm gonna write that down. So I'll say 4 is equal to 3 by 2 squared all over 2 minus 2 plus c. So now we had a find for c. So what's 3 by 2 squared over 2?
That's not a calculation. Okay, c is equal to 0.
You guess c is equal to 0?
Yeah.
Okay, that's interesting. But I'm just doing full calculations. Wow, that worked out real good. Get 4 is equal to 4. Yeah, c would be equal to 0. So then where's the equation for velocity?
Velocity will be equal to 3t squared on 2 minus t.
Right? And they want you to figure out the velocity when t is equal to 4. So we had a
So you just plug in 4 on t. 3 by 4 squared on 2 minus 4.
right, so tell me what you end up with.
20 meters per second.
Mira, that's an easy 6 mark sense.
Yeah.
Open back question, I gotta see it. I don't know, I feel like I will have to draw a graph. Unfortunately, I predict.
Don't say that, man.
No, but I talking the math god speaking to me, they tell me that all I gotta prepare for a diagram. So that is why you need mock test, I give all your diagram. Yeah. The spirit just talk to me. Yeah. So just know how to draw a diagram. Right? So Cheyenne, you could do 2023 with me. And I have a diagram for that. So we'll run through that. Right? So anybody confused by this question? Now is your time to tell me. Is anybody confused? Taking dollars or no? Everybody quiet. Let we try 2023 now. So Cheyenne, you ready for them? 2023, the real brain thing. The real brain thing. All of this is kinematics.
Wait, give me that one phone.
Because I want you to improve in this area. Remember any mock test you leave out all of this. So and make sure you're good with it. So get the question already.
A drone tracks the movement of an object in motion on the ground. Following movements are recorded. Moves at a constant velocity of 4 meters per second for 5 seconds. Its velocity increases uniformly for 3 seconds at
supposed to be at. I'm gonna just fix that one. Little typo. It is that one. Yeah.
10 meters a second. It moves at that velocity for 7 seconds. It slows uniformly until it becomes to rest after 4 seconds. Sketch the graph of the movement of the object.
First of all, what kind of graph this is? A velocity time and this a distance time. What kind of graph this is?
Velocity time.
Right. For those,
Reggie, just 1 second. But in the question we now do, is then has a displacement of 6 meters from O. That have anything to do with the calculation?
no, that don't have anything to do with the calculation. That don't have a single thing to do with anything. Yeah, it just it just there. It just there. If they did ask you to figure out the displacement, you would not need that. But it didn't ask you for the displacement. They just asked you for the velocity. Yeah. So it's just there to mislead you. Really. You understand me now?
Yeah.
You just put that there to tie up your head, to chin you up. Right. So for those who having trouble figuring out which graph to use, let me show you how we're gonna figure it out. Over here, they talk about constant velocity. They're talking about velocity and time. That's a big in there. They say the velocity increases uniformly. That's another big hint, because if it increases uniformly, you're gonna have a constant gradient. So you know we're dealing with velocity and time. And they're saying it moves at the velocity for 7 seconds. They're talking about velocity and time again. So it's a velocity time graph. Simple as that. So Cheyenne, you're gonna help me plot this graph. So a drone tracks the movement of an object in motion on the ground. It moves at a constant velocity of 4 meters per second for 5 seconds. If you could show me how that would look like.
Um,
So,
Hmm.
oh, Cheyenne, you're running into some trouble there. Let me ask that question. I want you to read back this question and tell me, did they say it started from rest?
no.
See, I can't assume a 0, 0. Can't assume that. So they're saying it moves at a constant velocity of 4 meters per second for 5 seconds, which means it didn't start from rest. Is right now it just started at 4. You understand?
Yeah.
Let me just put some, we just label this graph. 1, 2, 3, 4, 6, 7. Jonathan, I just don't see it right on the screen, all right?
Yeah,
I didn't hear you in so long. I swear you did.
he fell asleep.
Oh my God. That was crazy. Use a whole mood, yes? Bruh. Hold on. Wait. Okay, so Cheyenne, the sailor moves at a constant velocity of 4 meters per second for 5 seconds. So show me how that will look like.
See, on the x-axis, you must all be 6. That's not.
2, 4, 6, 8, 10, 12, 14, 16, 17, 20. Okay, yeah. Right? That's correct there.
Uh-huh.
Meet I understand what Cheyenne just now do.
Yeah, because they didn't say it was starting from rest.
Right. They did not say it was starting from rest. So it's starting, well, we don't know where it starts at, but we know right now we're going at a constant velocity of 4 meters per second for 5 seconds. And Cheyenne, what next happens?
Its velocity increases uniformly for 3 seconds at 10 meters per second.
Wait again, I call again. Give me a second. Okay. Cheyenne. So after I travel for 4 meters per second for 5 seconds, the velocity increased uniformly for 3 seconds at 10 meters per second. So show me how that looking like. I'm gonna go to the graph. So the velocity increasing to what? Tell me, Cheyenne.
10 meters per second.
And how long it taking to do that?
3 seconds.
So show me how that will look like. Just keep in mind, this is 5 over here. So
3 seconds. That's gonna be. God, that's gonna bend. Something like
yeah,
that.
well done, boy.
I know.
Okay. Right, and after you increase the velocity to 10 meters per second, You're saying it moving at that velocity for 7 seconds. You show me what that look like.
I'm gonna redeem myself
Let me see.
for 1 second. Okay,
Yeah, that's correct.
it's supposed to be at 15. Oh no, it is at 15. What?
It is 15.
Yeah.
Right. And what next?
It shows uniformly until it comes to rest after 4 seconds.
Okay. So, show me how that will look like. So after 4 seconds, it comes into rest. So show me what that line will look like.
What it goes then again. However,
Nah. Read back at it for me. So it slows uniformly until it comes to rest after 4 seconds. So that'll be 4 seconds after what?
after the 15, should end up at 19.
Yes.
Oh yeah, that's what I was trying to do when I got 10.
Oh, right. So I honestly don't think the question will come as hard as 2012. I doubt that. Judging by the patterns I'm saying, it will be something you can manage, I feel. Something you can manage. You wouldn't have to use any formulas or anything. Right? Right, so part 2. Calculate the distance traveled by the object in the second part of the journey. So Cheyenne, show me the second part of the journey.
This one is increased to 10. Yes?
Wait, let me just check that. Yeah, that is our one self. So it moves at a constant velocity of 4. That's the first part of your journey. Its velocity increases uniformly for 3 seconds at 10. Right? So we just label my diagram properly. So that's about it. That's the second part of your journey. So how much journeys we have then? How much parts of the journeys we have?
The 3 seconds only 10 meters per second.
Tell me how much parts of the journeys we have. How much journeys we have? So this could be one journey.
Um, 1, 2, 3, 4.
Right? And the easiest way to know that, look at the points. 1, 2, 3, 4. You understand?
Yeah.
So the ones to calculate the distance traveled by the object in the second part of the journey. So the second part of the journey they're talking about over here, right?
Yeah.
What kind of shape that looking like?
That's all I was.
See if you can tell me what shape that looking like. You know what shape that looking like. If you're having trouble, slant your head.
A rectangle. In a rectangle.
But that'll be a rectangle. A
I don't.
rectangle does look like that.
I know.
Think about it logically. In this topic, you had another area for 3 things: triangle, rectangle, and trapezium.
It's a trapezium.
Right, that is not a rectangle. It's not a rectangle and it's not a triangle. A triangle does look like that. It's got 3 sides. This thing over here have 1, 2, 3, 4, 4 sides. It's a trapezium.
So
So
to find the distance, it could be a half by 4 plus 3
4 plus 3.
by 10.
Nah. You're falling for the trick there. I thought it would trick you, you know. I'm gonna show you.
Oh,
Wait, again, another call away.
hmm.
Try to figure out the area any meantime. Cheyenne, if you want, you could ask anybody in class for assistance here, right? But all I'm saying is, going back just now, but if you this is what trapezium must look like. This is your parallel length there, and this is your other parallel length. This is your height. So imagine if you take the shape, and you rotate it like that. That makes it. So I'll come back in like 5 minutes. Okay, I am back. Cheyenne, do you figure out anything in the meantime? I mean, if you figure
No.
out. Okay. Let me show you anyway. I'm gonna show you anyway. So that's your
By 5 plus 3 by 10? Or by 15?
15. Wait, that.
No, I saying scrap.
So for a trapezium, right? This is what trapezium is normally look like. So A and B, those are your parallel lengths, and H is your perpendicular height. So imagine I take that shape and I rotate it like this. So then tell me, where's the height then? Compare the two diagrams. Where's the height? Did you get someone?
B, slant, B.
You
No,
said
A and B. Only height.
the
What?
height. The height is the distance between the two parallel sides. So the height really is this thing over here. That's the height. So what's the distance between those two lines? Much?
5, 6, 7, 8.
So what's the distance?
4,
4 now.
3.
3, yeah. And what is this length over here? No, it's 4, right? And the other one over here?
10.
10, right. So tell me, what are the two parallel sides then? What are the two parallel sides?
4 and 10.
Right? And what is the height?
3.
3. So let me plug it into the formula now. Okay. So the area will be equal to half A plus B by height. So A would be, what would A be?
14.
Nah, A wouldn't be 14. A plus,
10 plus 4.
but we were just put 14 there one time. And what's your height?
3.
So plug that into the calculator and let me know again.
Twenty-one.
Right? And where's the unit for that?
Tons.
Meters, yes. Right, and in part 3. What do you want us to figure out in part 3?
The acceleration and the final path.
Acceleration. In a velocity time graph, what gives you acceleration? The what? Where's them?
Gradient.
The gradients. So we had to find the gradient at what line? Show me which line we had to find the gradient for.
The last journey.
So highlight that from our circle.
That.
Yeah, that one self. Right? So to find gradient, how much points you need?
Up here. So 4.
Points, right? So choose a point from on this line.
519.
519. 519. You say 590?
519, yeah.
That will be somewhere over here. That point will be somewhere over here. Because it's almost 519. Remember, is the X first, then the Y.
Oh, 19.
Read off how, you gotta read off a point somewhere on the line.
Yeah, okay, wait. 19.5.
19.5. 19.5. If you're 19.5, that'll be over here. Then on the line.
Oh my god.
And choose a point on the line. So you gotta read off a point. So I'll help you here. The easiest point to read off will be this point over here. So this point over here. And this point over here. So read off this point from over here.
It's 15.10.
That will be 15.10.
Yeah.
I'll read off this point over here.
19.0.
Yes. So which one you want to say is x1, y1, and which one you want to say is x2, y2? Up to you.
X1, Y1, 15 and 10. Y1, Y2, 19 and 0.
Right? What's the formula for gradients?
Y2 minus Y1 over X2 minus X1.
Right? Say no more. Right? It's the correct thing. So tell me what to plug in into that now.
Minus 9.
That will be, tell me that again. 0
0 minus 10 over 15 minus 19.
Nah, it's x2 minus x1 and x
90,
90.
19 minus 50.
Right. There you go on that one.
It's minus 10 over 4.
You get minus 10 over 4.
Yeah,
Right, and where's minus 10 over 4 as a decimal,
that's 2.5.
right? So the acceleration is minus 2.5, and where's the units for acceleration?
Meters per second.
Nah, is meters per second squared. Meters per second squared. Right, and that's nice. Still have more to do. But how was the graph defined, Cheyenne? Was it easier than the other ones?
I don't know. I don't like that.
Wait, some?
I don't know. I don't like it.
Shweta, what do you think about the graph in 2023? Shweta? Hey, Shweta. So, Cheyenne, let me move on to the other part in 2023. So, I want you to read 2023 from now.
Consider a toy truck moving along a miniaturized racing course with an acceleration of at is equal to 9t squared plus 2t minus 1, where t is the time in seconds. Assume that the speed of the truck is measured in centimeters per second.
Okay, so they give us the equation for what?
Acceleration.
Right? Acceleration is the same thing as what? Coming into differentiation.
The a over the
No. Acceleration is a change in velocity over a change in time.
dv over dt.
Alright, so if I wanted to get velocity, what would I have to do?
Integrate.
How do I integrate that? So read part one from now.
Outline how an equation for the speed of the truck would be found using the given equation for the acceleration.
So outline how an equation for the speed of the truck could be found. So speed is basically the same thing as what? Speed is like the same thing as what?
Velocity.
Right. And they are asking you to say how you go find that equation. How you go find that? What you would have to do?
Integrate.
Right. See, you would have to integrate. Great. And that's where you get 1 mark. You just integrate it, right? Good, so Cheyenne, I'll wait to read part two.
When the speed of the truck actually equals 10 seconds.
Now, do we have the equation for speed as yet? Do we have that?
No.
No, so we had to find fit. And how are we going to find fit?
Integrate.
Right, so I'm going to integrate the acceleration. And acceleration is the same thing as what, Cheyenne? Just remind me. What is this?
Velocity.
Acceleration. I can write acceleration as what? In terms of differentiation.
dv over dt.
Right, so if I integrate dv over dt with respect to time, that would give my velocity, right? And dv over dt, that's acceleration. That was given to us as 9t squared plus 2t minus 1. So our way to integrate this one.
You'll get 9t cubed over 3 plus 2t squared over 2 minus 1 plus 2.
That's what you're talking about?
Yeah, minus t here.
Minus if you're getting somebody.
Minus plus c, plus c, plus c, plus c.
So I'm a little bit muffled, right? Plus C. Now, here what? We had to find for plus C, yeah? And find for plus C. And we need a condition for that. We need a condition for that. So, Cheyenne, this
C
question,
equals to 0.
tell me that again.
C is equal to 0 and b is equal to 0.
Right. And now, if you're having trouble figuring that,
Assume that
if you're having trouble figuring that out, right? Imagine you have a toy truck. If you didn't start it, I mean, if it's a toy truck, obviously you will start at rest. Because if you don't turn on the switch, the time will be 0 and the velocity will be 0. So at the start, the toy truck will be moving at a speed of 0. What is it, Sean?
the integration, you could simplify the integration part a little more.
Yeah, we can do that. So tell me what will be if I simplify it.
C cubed plus t squared minus t plus c.
Right, then we have to find for C now. So anywhere at CV, we're going to replace it for.
3t cubed plus t squared. Not 2t.
You're asking again. Anywhere at CV, we're going to write.
Yeah, I know. Fix the equation. T squared, not 2t.
Yeah, and anywhere at CV, we're going to write.
It's t squared, not 2t.
What's up?
Rajiv,
Yeah.
why are we assuming t equals to 0 and v equals to 0?
We are assuming that so that we can find the constant C. But I'm going to explain in terms of the question. So, Meta, give the question I read from them.
If they don't give you a condition, you would have to assume that the rest is 0 to find the c.
Yes, you would have to assume that. Now, read the question, and you can see why I say that too.
Consider a toy truck moving along a miniaturized racing course with an acceleration of a equals to 9t squared plus 2t minus 1, where t is time in seconds. Assume that the speed of a toy truck is measured in centimeters per second.
Okay, so Meta, all right, if you, let me just say buy a toy truck for cash. When you take it out of the box, is it moving?
No.
No, so at time is equal to 0, your velocity is 0. You didn't start it as 0. Simple explanation for that one. If you set up a toy truck on a racing course, initially, at time is equal to 0. Before you start it, your velocity is 0. Let me know if that makes sense.
Yeah.
Right? So, tell me what to write, child.
So it's not 2t squared, just t squared.
Oh, that's what you're saying.
Yeah.
I wasn't hearing you properly. Yeah, that's correct. The 2 and the 2 would cancel out,
Mhm.
right? So tell me what to write.
V is equal to 0 is equal to 3 by 10 to the power 3 plus 10 squared minus 10.
Wait, where you get 10 from? We have finished yet, huh? We have finished yet. Gotta find for C. We know C gonna be 0, but you still have to show that. So you're gonna plug in the condition. So V is equal to 0 and T is equal to 0. So then C will be equal to 0.
Yeah.
So now I can write the final equation. So V is equal to
3 by 10 to the power 3 plus 10 squared minus 10.
wait, nah. After you find for C, you just have to write back the equation one more time. Like, Cheyenne, let me just say C wasn't 0 and C was actually 9. You had to put that over here. You had to say that before you plug in the 10. Just be careful of that.
Yeah.
Um, right? So now you can plug in the 10. So that'll be 3 by 10 cubed plus 10 squared minus 10. So plug that into the calculator and let me know what you get.
Look at 3090 centimeters per second.
Right. And what about part 3?
Find the distance covered by a chalk between 5 and 10 seconds. Express your answer to the nearest full number.
You have two values. What does that suggest? You have two values. Add it now. Yeah, well, find the distance. The way to find distance, right? We just now find the speed or velocity. Velocity is the same thing as what? Remind me, velocity is the same thing as what?
Acceleration.
See Jonathan drawing. So, Tran, velocity is the same thing as the change in displacement over the change in time. So if I have to get the distance, I would have to then integrate this. So the 5 and the 10, my hint was that the 5 is the lower limit and 10 is the upper limit. Yeah. So if you want to get distance, you actually have to integrate velocity because velocity is ds over dt. So now we equal to the integral of, what was my velocity again?
3t cubed plus t squared minus t.
Right, and if I integrate ds over dt, what can I end up with?
3 power 4 over 4 plus t cubed over 3 minus t squared over 2.
Wait, I mean the left hand side. If I integrate ds over dt, what will remain with? What will I end up with?
Distance.
Right? Just S, and the S stands for your displacement for your distance. And over here, one thing, Cheyenne, they gave us a lower limit and an upper limit, so we had to put it in our equation. So my lower limit is 5, and my upper limit is 10. Right? So since it's a definite integral, I'm going to put square brackets and I'm going to integrate. Put some of that one more time. That'll be 3 theta what power?
3 power 4 over 4 plus t cubed over 3 minus t squared over 2 plus c.
Is that plus C?
Yeah.
Nah, this is a just
It
for
have
the
a plus c. It will have a plus c.
you wouldn't power plus C because you have a upper and lower limits in this case.
Yeah.
So tell me what to write next.
Distance is a little undefined.
So that again?
Distance is a little undefined.
Yeah, you gotta plug in E10 and 5 and then minus it from each other. So let me plug in E10 first.
Maybe 3 by 10 to the power 4.
It's right, so plug that into the calculator and let me know what you get.
Make a plug that whole thing in it.
You can plug that whole thing in.
get a big number?
Yeah, just get a big number.
Right? You know my son with that too?
With a what?
With that too.
Nah, so start with a 7.
Okay. 7285.
Yeah, I'm supposed to start with a 7.
Okay, we get 7285.
Yeah, I guess 7285. It's only, it'll be centimeters. Meter, let me know if you're confused by this. You understand this part. You guys understand this?
Yeah.
Okay, so let me just recap before we move on to the next topic, which is strings. First things first. Velocity is the same thing as what? How to write velocity in terms of differentiation?
Yeah, so what is it?
Right? ds over dt. And acceleration. Acceleration is what in terms of differentiation?
So what is it?
dv over dt, is it?
Yeah.
If I wanted to figure out the velocity and I get acceleration. So I have acceleration and I want to get velocity. What how to do? So I have dv over dt and I want to get v.
So I get the DS so what is it? No.
So here is a Shyam, you want to go from acceleration, which is dv over dt, to velocity. So we got to do the acceleration to get velocity.
Centimeters.
Right, so? Yes, because if you integrate, you get rid of the differentiation and you're going to v,
Okay.
right? So if you're going from a to v, you have to integrate. Okay, if you're going from v to a now, we got to
Integrate V.
integrate v. Nah. Shan, take your time, right? So velocity that is remind me, what's velocity?
Yeah, so what is it?
And acceleration as well.
dV over dt.
So what would I have to do with velocity if I want to get dv over dt?
Integrate it.
Integrate it, nah. Differentiate it.
Oh, because you're going after that.
Look at it, dv over dt. That means to differentiate v with respect to time. Right? Then we just are going from displacement to velocity. Right? Displacement is just displacement. Remember, where's velocity?
DS over dt.
So what you had to do with displacement to get velocity?
Integrate it.
So why is it integrate? Let me think about it. So you're trying to go from s to ds over dt. ds over dt, that means you differentiated it. Check it out. ds over dt, that means you differentiate and your displacement with respect to time.
Okay.
Let me try another one. If you're going from velocity to displacement, how are we gonna do that? First of all, tell me, what is displacement? Sorry, not displacement, velocity. Velocity is what?
DS over dt.
So what I have to do with this to get back s.
differentiate it.
Right, I would have to integrate it to get rid of the differentiation. Right, so let me just pick you back up on it. If I have acceleration and I want to get velocity, remind me, what is acceleration?
dv over dt.
And I want to get back v. What I had to do?
Integrate it.
Right, I had to integrate it. If I have v and I want to get a, what I had to do?
Differentiate it.
Right, because a, remember what a is.
A is dv over dt.
Right, so I got to differentiate v to get acceleration.
Yeah.
I think you get the gist of it now, right?
Yeah.
And when you're doing kinematics, you have two kind of graphs you need to know. You need to know,
Velocity time and displacement time.
for a velocity time graph, the gradient gives you the what? Right? Acceleration. This over here is positive or negative acceleration,
This is
right? Because you're increasing your speed. This over here, positive or negative,
negative.
right? And what kind of shape that is, Shannon?
It's easier.
Right. If I were to split up this into parts, what shape is this?
It's a triangle.
That's a triangle. What shape is this?
It's a rectangle. Because I got a square.
A rectangle. And what shape is that?
Triangle.
So sometimes you will have to do that in your diagrams. Sometimes. So Shannon, how much do you need to have in this question? How much do you need to have?
3.
Yeah, 3 joules, yes. Right. Now, displacement time. So for this one, the gradient, it gives you acceleration. If you have a gradient like this, what does that say about the acceleration? Does that mean you're accelerating?
Yeah.
No. If I go in at the same velocity, I'm not accelerating.
I thought you were asking the next one.
Nah. Let me just finish up this one here. So if you have a gradient like this, that means you're going at a constant speed.
Yeah.
And if you find the area under the graph for the velocity time graph, what does that say?
Distance.
Yes. Let me just say I had this over here. What shape is that?
That's easier.
Easy. Tell me how I go find the area of the shape.
So half by 7 by 2 by 9.
Come on, one more time.
Half by 7 plus 2 by 9.
Yes. Seems like you get everything there. And if you have a graph like this is a displacement time graph. This over here means you're moving away from your starting point. This over here means that you're staying at the same place. And this over here means that you're moving towards your point. Yeah. So this over here is positive gradients. That means you're moving away. Moving away. This over here means that you're staying at the same place. And this over here means that you're moving towards. and the gradient for our displacement time graph. What is given? Come on, come on, Sean. The gradient for displacement time graph. Does anybody know what displacement time is given? Like if you find a gradient on this graph. Speed, yes. Okay, so that's basically it for kinematics. So here we'll take a 10 minutes break. And when we come back, we're gonna move on to trigonometry. I should take a 10 minute break. We finish in class 3 o'clock. 3 o'clock. All right, guys, are you all back?
Yeah.
Okay, so let's move on to trigonometry now. So, okay, so let me just give you all a quick overview of trigs. All right, so first things first, we need to know how to find the area of a sector and the length of an arc. So who wants to run through this with me? Cheyenne, I feel like you should do that, you know, because this was giving you some trouble. Cheyenne? Jonathan, it's just you in class. Meta, Hirama?
Yeah.
Okay, so Meta. I'm not hearing Jonathan and Cheyenne. She instead of giving trouble, so I'll run through it with you. So do you remember the length of an arc and area of sector? So do you remember those formulas? Not hearing anybody, so I'll continue. Right? So let's just say you have a circle. A sector comes like a piece of the circle. You can imagine you have a pizza. One of the slices would be a sector. So you have length of sector, and this over here would be area. That's the area. So if you want to figure out the length of a sector, the length is given by r theta, where theta has to be in radians. And the area of sector, that's a half r squared theta. And again, note theta must be in radians. Right. So let us handle a question where they are asking us to figure out length of sector and the area of sector. We get a question. Okay, so this is a nice question. All right, so in this question, they give us a diagram where the radius is 4 centimeters and the angle is pi over 6 radians. Now, it's also important to note that pi is equal to 180 degrees. So just keep that in your mind, guys. Pi is equal to 180 degrees. Now, you should also know how to convert degrees to radians. So, first of all, if you want to convert degrees to radians, you're going to use this over here. So first you find for 1 degree. So 1 degree would be equal to pi all over 180 degrees. And from here, you could figure out what any angle is. So let me just say we had to figure out for 7 degrees. That would be equal to pi over 180 degrees multiplied by 7. So if you wanted to know how to convert degrees to radians, now you know. So let's check this question out. They want us to figure out the area, the shaded region over here, the shaded region. Now I want you to imagine it like this. The shaded region, that come like this whole region over here, minus this shaded region over here. So if I want to figure out the shaded region over here, I would have to find the area of the sector, and then I would have to minus it from the area of a triangle. So I'm gonna do that. First things first, if I want to find area of my sector, that is r theta, right? So area of sector, that would be equal to, sorry, a half r squared theta. So my radius is 4, and my angle is pi over 6. So that'll be half of a 16. 4 by 4 is 16. So half of 16 is 8. So you'd end up with 8 pi over 6. And you can simplify that. Typically, in these questions, you want to leave your answer in terms of pi. So 8 pi over 6, we can simplify that. 2 into 8 is 4, and 2 into 6 is 3. So you really end up with 4 pi over 3. So the area of the sector is 4 pi over 3 centimeters squared. Now that is the area of this whole thing over here. But we want to find the area of this small region over here. So the next thing you'd have to do, guys, you would have to find the area of a triangle and subtract it from this whole thing over here. Right? Like so. So the area of sector is this. This is the area of the sector. Now we're going to find the area of the triangle. Now, they told you what the area of the triangle is in the question. They said, if the area of the triangle AOB is equal to half r squared sine theta, then calculate the area of the shaded region. Anytime you see pi and thing, put your calculator in radians mode. Especially when you're doing trigs in AdMaths. The calculator have to be in radians mode. So to figure out the area of the triangle, I'm going to use this formula here. A half r squared sine theta. All right, no problem. So the area of the triangle, that is a half r squared sine theta. So that would be equal to a half. Your radius is 4. And your angle is pi over 6. Right, so if I plug that into my calculator, I'll tell you what I'm getting. So that'll be half of 16 again, so that'll be 8 by sine pi over 6. And that would be equal to 4 centimeters squared. Right. And that is the area of the triangle. So then if I have the area of the triangle, it's really simple to figure out the area of the shaded region. Just make this red. Right? So if I wanted to figure out the area of the shaded region, I would just subtract the 2. right? As you can see, we have our overlapping region that will cancel off, and the remaining region that will be a shaded region here. So area of shaded region that will be equal to 4 pi over 3 minus 4. Right, so let me plug that into my calculator.
This is the first question we do on it.
Yeah, this is the first question. So if you put 4 pi over 3 minus 4 into your calculator, you're supposed to get 0.19. 0.19 cm squared. Shan, let me know if you want me to re-explain the question.
No, I understand.
All right, no problem. Right. All right, so that's the first question. So again, guys, you need to know that the length of an arc is r theta, area of an arc is a half r squared theta, where theta must be in radians. So you all could try a bunch of questions. There are a bunch of questions involving the length of an arc and area of sector and things. So you all could try the questions and send to me. But before I move on, let me just do this question here. I want to do this question. Right, so Cheyenne, if you're able, I'll wait to read that question for now.
Commercial sector OAB of the circle with center O radius 9 and angle 0.7 radius. Find the area of the sector OAB.
All right.
I use a half r squared theta.
Yeah, we had to use a half r squared theta, but that is not all, eh? That is not all. Because Cheyenne, I want you to shade the region that will be the sector. If you find a half r squared sine theta, sorry, no, not half r squared sine theta, just a half r squared. A half r squared theta. True mathematical. So if you find the area of the sector, shade the region, it'd be fine and full.
OAB, so that is this part.
Yes. And we
So
have to
then
figure out
you would
this.
we had a minus this from that.
No, you gotta minus the area of the sector from the area of the whole triangle. So first of all, let me figure out the area of the sector. Oh, and the first part is just wait to find the area of the sector, so it was correct. Is the second part we got a minus.
Oh yeah, the shaded region. There's just the area of the sector and the triangle minus 2.
Yes. Ice cream man passing in the background.
Yeah. Must be nice.
Right? So let me do this question here. So if I want to find the area of a sector, where's the formula?
A half r squared theta.
Right? Where's the radius?
Radius is 9.
And where's the angle?
0.7 rad.
Make sure your calculator is in radians mode and plug that into your calculator.
You will get 28.35.
You get 28.35.
Yeah,
Where's the units for that?
centimeter squared.
Right. So I want you to imagine that's the area of the sector.
Mm-hmm.
That's just over here. And so how would I find the area of the shaded region?
Well, we gotta find the area of the whole triangle first.
Yep. How would I find the area of the whole triangle? Very good.
R squared. This,
Half r squared sine theta.
yeah. So give me a half of 9 squared by 0.7. Well,
Wait,
sine 0.7.
you can't assume that. The only reason you can use that formula in this question is because the triangle, it was an isosceles triangle.
Oh,
But this is not isosceles triangle. That's not isosceles. So yeah, I'm gonna show you what you gotta do.
yeah.
You gotta use the sine rule. So here what we label with triangle. So this could be small c. What this could be?
Small e,
And this will be.
small e.
Oh wait, it's not right angle triangle. Since it's a right angle triangle,
That's a totally thingy.
you could use for it's a right angle triangle.
Six.
Yes, we could use tricks. Right, so which is the hypotenuse? Where's the hypotenuse?
That is the
Right, but thinking. Let me try something. So there's a formula for area of a triangle. I think it was half AB sine C. I think that's the formula there. Half AB sine C. Now this formula does work. This formula does work whenever you have a included angle. So let me just say you have an included angle. This is A, this is B, and this angle over here is angle C. So, Cheyenne, I'm gonna move on, right? If we have to figure out the area of this triangle, we would need an included angle. Do we have any included angles? An included angle is an angle between two known sides. Two known sides. So like you have 9 centimeters over here, but you have any angles over here?
no.
So we had to find for this side here. And we're gonna find for that side using one.
Pythagoras.
Yeah. So this over here, this is the hypotenuse. That's the hypotenuse there. Actually, you can't find paid using Pythagoras, you know. For you to do Pythagoras, you must have at least two sides. But over here, you just have one side. So you have to use the trig ratios. So we're gonna label this over here, this is the hypotenuse. What is this?
Yeah, this one.
That's my adjacent, right? Right next to the angle. And this over here is here. So we're trying to find for the hypotenuse, and we have the adjacent. So which trig ratio will I use? Which trig ratio have A and E to it?
Ah.
Right? So we use cos theta is equal to A over H. Where's the angle?
The angle is 0.7.
That'll be equal to A, which is 9, all over H. So how we go find for H then?
Multiply by each.
Right? I multiply by H, I end up with H cos 0.7 is equal to 9. I want to do next.
Divide by cos 0.7.
Yes. All right, so plug that into the calculator and I'm gonna
get 11.76.
11.76.
Yes.
All right.
Well, 11.77 if you round it off.
Very on top of that. So, Cheyenne, do we have a included angle now?
Yeah.
Right? Because we know the two lengths for these sides are next to it. So then I'm going to use the formula, a half AB sine C. Let me show you how we're going to use our formula. So is a half A and B, those are the sides right next to the angle. So tell me, what are the sides right next to the angle?
9 and 11.6.
Right? So that will be a half by 9 multiplied by 11.76. Right? Sine what? What's the angle?
0.7.
Right? So plug that into the calculator and let me know what it is.
Um, 11.77. 11.6. We round it off.
Wait again?
The one this side is 11.77, not 11.6. No, just 11.76, 11.77.
Uh-huh. Yeah. I should plug that into the calculator and let me know what it is.
You get 32.1, I mean 34.12.
And that's the area of the whole triangle. Whole triangle. Right?
Yes, 34.12, we have a 0 after.
34.12.
Yes,
Right? And that will be centimeters squared. I don't know what meter over here. 30 centimeters. And this will be. So now if I wanted to figure out the area, the shaded region, all I have to, which is minus it. Right. So that area that'll be equal to 34.12 minus 28.35. So plug that into the calculator and let me know what you get.
5.77.
5.77.
Yes, centimeters.
Right. So just be very careful, right? Sometimes you need to know this formula, a half AB sine C. And you can only use this formula when you have an angle between two known sides. Just be careful of that. All right, the next thing you need to know in trigs, you need to know double angle formula and them kind of thing. So let me look at the compound angle formula first.
We go into class 3.
Where is it?
We go into class 3.
Nah, have a class after.
Oh.
So I'm moving with speed. So the compound angle formula you have, the main ones you need to remember is so we have sine A plus B. Then I have sine A minus B. Then I have cos A plus B. Then you have cos A minus B. So sine A plus B, that is sine A. Fine, if you remember, I'll call it out, right? Sine A.
Sine A over, oh, that. Sine A cos B plus sine B cos E.
Yeah.
Cos E cos E sine B.
How about sine A minus B?
Sine A cos E minus cos E sine B.
Right? And how about cos A plus B?
cos A, sin B,
Nah, it's cos A equals B.
oh, plus sin
Nah.
A, sin.
It's a little bit.
Oh yeah, that's it. 1, 1, 1.
Yeah. You remember? You well remember. Right? Minus sin A, sin B. And what's over here?
That is cos A, cos B, plus sin A, sin B.
Right, so let me do a question with this one time.
Wait, if I just go back to last time, let's move the picture to calculate long after.
No problem.
Okay, we got
All right, so another thing you need to know about, complementary angles. Let's put that down to the side. Complementary angles. Let me get an example of a complementary angle, right? An example is sine 60 would be equal to cos 30. Cos 30 would also be equal to sine 60. Another example is sine 45 is equal to cos 45. Now, cos 45 is equal to sine 45. I don't want to put this, right? Another example is like what you could say sine 20 is equal to cos 70. Cheyenne, we notice about the angles here. Like if I add up 60 and 30, we're okay.
90,
If I add up 45 and 45, we're okay.
Right.
If I add up 20 and 70, we're okay.
90.
So once it adds up to give you 90, they're the same angle. So I'll show you how to apply that over here. All right, so Cheyenne, give this question a read.
Given that sin pi over 3 is equal to root 3 on 2, cos pi over 3 is equal to a half, and sin pi over 4 is equal to cos. And sin pi on 4 is equal to cos pi on 4 equals the root 2 on 2. Evaluate the using calculators the exact value of cos 7 pi over 12.
Okay, here what to do. This is radians and confusing me big time. So convert degrees. So pi over 3 is how much degrees?
60.
60. Yeah. Pi over 3 again, that is 60 degrees. So let me answer that question, Cheyenne. If sine 60 is root 3 over 2, what do you think cos 60 will be? All right, cos 30.
60.
No. Wait a sine 60 is equal to root 3 over 2. So what do you think cos 30 will be?
Root 3 on 2.
Right, because they are complementary angles. They will add up to get back 90. So that's just something to know. Right? Pi over 4, how much degrees is that?
That is 4.
Pi over 4, how much degrees is that? Remember, pi is how much degrees?
180.
Right? So where's 180 over 4?
45.
45. And then sine 45 will is equal to cos 45, right? And 7 pi over 12. Convert that degrees for me.
That'll be 105.
That's 110,
105.
105. So Cheyenne, Selma, what would I have to add to get 105? Look at everything you have here and tell me what you would have to add to get 105.
145.
60 and 45. Right? So I think, boy, I don't know if they're gonna take away marks if you write it in degrees. But here what, let me just stick with radians, right? So Shan, to get 105, you would add 60 and 45, right?
Yeah.
So 60 is the same as what's in radians,
Pi over 3.
right? So to get that'll be pi over 3 plus,
Pi over 4.
right? And you had to use the compound angle formula there. So
Yeah.
that'll be cos what?
Pi is cos A cos B.
Right? So where's A over here? We take them as a- Yeah. So where's A and where's B?
Cos pi on 3.
Right? So that's
And then cos pi on 4. Minus sin pi on 3 and sin pi on 4.
right. Right. So remind me, what is cos pi over 3?
Root 3 on 2.
Nah. Look at everything there. What is cos pi over 3? Everything,
Uh-huh.
right? Cos pi over 3 doesn't have. What is cos pi over 4?
Root 2 on 2.
By chance, I want to plug that into your calculator and tell me if you get root 2 over 2. Put cos pi over 4.
Hmm.
So make sure your calculator is in radians mode as well.
Oh. Root 2 on 2, yeah.
Okay, nice. So yeah, even if they do give you this in your exam, it should be good because you have a Casio. Nice. And sine pi over 3. Where's sine pi over 3?
That is root 3 on 2.
Right? And what is sine pi over 4?
Root 2 on 2.
Yes. And here what? You're not gonna plug this into your calculator. You have to do the calculations manually. So what is 1 by root 2?
Root 2.
Right? And what is 2 by 2?
Root 4.
4. And what is root 3 by root 2?
Root 6.
Right? And what is 2 by 2?
4.
Do they have the same denominator?
Yeah.
Right? So we can just combine them. That'll be root 2 minus root 6 all over 4. That's what they mean by exact value. Right? So you need to be able to handle questions like this. So we kind of over time, so I just do an example of every kind of question you're gonna need to know. Right? You need to know how to handle a question like that, where you have to either add 2 angles or minus 2 angles. If the radians confusing you, convert it to degrees and work with it. Worst case scenario. Next thing, you need to be able to work with, you need to be able to do trigonometric equations. So Cheyenne, when you're doing trigonometric equations, aren't it? What is the main identity you need to know?
1 minus. Is it 1 minus cos theta thing and 1 minus sin theta thing?
Yeah. Oh, by the way, on that compound angle formula, you also have double angle formula. So I should do that one time. But the main thing you need to know is that sine squared theta plus cos squared theta is equal to
1.
right. So share double angle.
You said this is backwards, right?
Yeah, of course. So this.
I'll write it down.
Yeah. So the double angle formula. Double angle formula is cos 2a. Instead of a, they could write theta and thing. And you have sine 2a. So Cheyenne, for me to get sine 2a, that'll be sine what plus what? To get 2, that is what plus what?
Sin A plus A.
Right? And we will use the formula for sine when you add in two signs, like sine a plus a, that'll be equal to, use the formula.
Sin A plus A.
Right, so that'll be sine a cos a plus
Sin B cos.
nah. In this it don't have a b. It just b.
Cos A sin.
Right? So let me ask that question. Is sine a cos a different from cos a sine a?
No.
Nah, if I say 4 by 5, 4 by
Way.
a brain not functioning, I rather get I'll drink some energy drink or something. Question is 4 by 5 different from 5 by 4?
No.
Are the same thing. So this is what we're gonna write. So sine a plus a, that's the same thing as 2 sine a cos a. Yeah. Depending on how wicked they are, this could come any proofs. Like trick proofs, you're gonna need to know this. And cos 2a, to get cos 2a, that'll be what?
Cos A plus A.
And you see compound angle formula there again.
That will be cos A sin A.
Again, yeah, I know be careful. Be
Yeah,
careful.
cos
In this, the a come like a and the b come like a.
cos A cos A.
Right? Cos a cos a. Continue.
Minus.
Okay.
Minus.
Minus.
Sin A sin A.
Yes, that's correct. Because if you notice in this case, we have a and we have another a, right? And it's the same story if they give you something like 2 theta or something. Because Cheyenne, if I want to get sine 2, let me just say I want to get sine 2 theta. To get sine 2 theta, that will be sine what plus what? If I wanted to get 2 theta,
Theta plus theta.
right? So let me continue with this. Yeah, what is cos a by cos a?
Cos A by cos A.
Yeah.
Cos 2A.
Nah.
No,
If I
cos
ask
squared.
you 5 by 5, what are you talking about?
Right.
Right? That is not 2 by 5, that's 5 squared. So the cos squared a minus what is sine a by sine a?
Sin squared A.
Right. And remember, what is the main identity you need to know?
Sin squared A plus cos squared A is equal to 1.
Right. This is the main thing you need to know. And from that thing there, tell me, what would sine squared a be equal to?
1 minus cos squared A.
It's coming back to you now. And cos squared A, that'll be equal to,
1 minus sin squared A.
right? So in cos 2A, you have two different routes you could go down. If you want to if you want to write it differently, I'm gonna show you the first method. You convert cos squared to sine squared. So cos squared is the same thing as what?
A by cos A.
Remember, what is cos squared?
Cos A by cos B.
Right, but what is it equal to? What is it equal to?
Oh, 1 minus sin squared A.
Right, so I can write it one of two ways. I could replace the cos squared A for 1 minus sine squared A. So then I will end up with what? Where is 1 minus sine squared A minus sine squared A?
1, 1.
So you have a minus sine squared and you have another minus sine squared. You're minusing them from each other. How much minus sine squared A's you have?
2.
So that'll be minus 2 sine squared A.
Oh.
Let me know if you understand that.
Yeah.
And this is one way you can write cos 2A. Okay, the next way we can write it. I'm gonna show you. So we replace cos squared for 1 minus sine squared. What do you think is the next thing we could have possibly do?
Replace sin squared for my 1 minus cos squared.
Yes. So that'll be cos squared A minus open bracket. You need to put the open bracket there because sine squared A is more than 1 term. So that'll be cos squared A minus 1 minus cos squared A. I'll wait to expand that for now.
Minus 2 cos squared A.
Minus,
Plus.
wait, be careful. So the minus will multiply by the,
Minus cos squared A.
again, the 1. Yeah, the 1. So the minus will multiply by the 1. What is minus by 1?
Minus 1.
And what is minus by minus?
Positive.
Right, so you're gonna put cos squared A minus 1
Mm-hmm.
cos squared A. So how much cos squared A is you see it?
2.
So that will be 2 cos squared A.
Minus 1.
Yep. And as the other way, you can write cos 2A. So truth be told, I have 3 different ways you can write it. 1, 2, and 3. Right. So now that you know the double angle formulas, let's move on to trigonometric equations now. Trigonometric equations. All right, so let me try this question here. So in trigonometric equations, at this level, most likely you'll end up with a quadratic or something, right? But what you will have to do, you will have to convert everything to the same trig. So Cheyenne, over here, you see a mixture of what?
Cosine sine.
And for you to work, you must end up with one trig, not one trig, right? So can you convert cos squared to sine?
Yeah.
But can you convert sine to cos or something?
No.
No, it had to be squared, right? So we could convert cos squared theta to what?
1 minus sin squared theta.
Yes. Right. So I can write that as 2 open bracket 1 minus sine squared theta.
Mm-hmm. Plus 3 sin theta. You will get 2 minus 2 sin squared theta.
Right. Right. So I want you to rearrange that and pay it like if it's a quadratic. So I want you to think as sine squared theta like if it was x squared.
Okay. so it'll be minus 2 sine squared theta plus 3 sine theta.
Wait, you just want to say cos squared?
No, sine.
It's okay. All are we to add? I understand. So it'll be minus 2 sine squared theta.
I see that.
Yeah, that's what you say cos.
Because- No, plus 3 sine theta plus 2 equals 0.
Right? And here what? Let me make this simpler for us. You're gonna say let y be equal to sine theta. Right?
It'll be minus 2 squared.
Now take your time. You said minus 2 squared just now. Take your time. So if we say in sine theta is y, what would sine squared theta be? So try and think about it. Sine squared theta. That is what by what?
Sine E by sine E.
Well,
Or sine theta.
sine theta by sine theta. So if we say in y is sine theta, sine squared theta will be what?
Sine theta.
Say that again.
Sine theta.
Sine theta. Nah. Here what? If y is sine theta, then sine squared theta will be y squared. Because we say if we say y is sine theta, then check it out. I mean, if you understand.
Yeah.
And then call out the rest of the equation.
Plus 3y plus 2.
Yes. Now we need to factorize that. So to get back minus 2y squared, what can I multiply?
Minus 2y by y.
Right? And to get back 2, I can multiply.
1 and 2.
Right. Now if I put the 1 and the 2 over there, the minus 2 will multiply by the 2 and I'll get what? Where's minus 2 by 2?
Minus 4.
Minus 4. And then you go add minus 4 to 1. You're gonna end up with what? Where's minus 4 plus 1y? Minus 4 plus 1.
Minus 3.
Right. We gain back positive 3.
No. So you
No.
gotta put 2 by the 2y.
Let me see if that will help. But that will look like it will help. Because then I'll get minus 2y plus 2y and then I'll be 0. So Cheyenne, you have any other ways you can multiply to get back 2? So a positive by a positive is a positive. Come on the other option.
2 minus.
So
Minus 2 by minus 1.
minus 2 by minus 1, yes. So let me try that now. What is minus 2y by minus 2?
4y.
And what is 4y minus 1y?
3y.
Right, so we get through it. Right, like I say, if it's giving you trouble in the exam, forget about the factorization, just plug it into your calculator with speed. If someone giving you trouble and it's like this, move on. Don't spend time on it. So we have minus 2y minus 1 is equal to 0, and we have y minus 2 is equal to 0. So then if I make y the subject of the formula, y would be equal to minus a half. Just double check that for now.
Yeah.
Is that correct?
No, I could just be a half.
Nah, it wouldn't be a half because when you move across the minus 1, you're going to have a positive 1. And when you divide by the
Oh, yeah.
negative,
Minus.
can you spot the imposter? Can you spot the one that's wrong?
Minus a half.
A minus half is correct. You're talking? You're saying that because our logs and thing. That's why you're saying it's invalid. But this is truth. What was the trig with? So we dealing with sine, right? Dealing with sine. Are we dealing with sine?
Yeah.
We did say y was equal to sine theta. So sine theta is equal to minus a half, and sine theta is equal to 2. How the sine graph does look again? Remember?
Yeah.
See if we can sketch it from the
This
And it is go up to what and it go down to what?
my 1 and minus 1.
That's it.
So the base,
So it doesn't go up to 2.
yeah.
This could be invalid.
Good.
So
Yep.
sine and cosine graph, the both of them only go up to 1 and down to minus 1. Be careful of that. Right? So we have sine theta is equal to minus a half. The next thing you're going to do, be careful. The next thing you're going to do, you're going to find your reference angle. And your reference angle, we call it alpha. To find the reference angle, you're going to find sine inverse of what? You're going to find sine inverse of minus a half or positive a half. Is it
Positive a half.
positive a half? Because the reference angle is being what quadrant? First one, right? So you remember the quadrants?
Yeah.
So
AS species.
all school teacher
Silent was
plus. So let me find sine inverse of a half. Plug that into the calculator. Note, I want you to note something, Cheyenne. In the question, they were to get the answer in terms of degrees. So go back to your calculator on degrees.
yeah. You go. Yes, please. City.
30 degrees, right? Cheyenne, is that one of my answers? Like if I put 30 into sine, would I get minus a half?
No.
No, I'll get positive a half, hence.
Yep.
So I'm just doing this to actually find my answer. So what am I gonna my reference angle, that's on my first quadrant and it's 30. You remember how it's constructed 30 degrees?
Not.
You remember how to construct 30 degrees from the crash course?
Yeah.
Nice. So we're looking to see where sine is actually where. Sine is what?
Minus a half.
So where sine is negative,
Negative, yes. So you're being third quadrant.
it will be in third quadrant, you see?
Yeah.
And which other quadrant?
Third and fourth.
Yes. I see everything coming back to you. Love to see it.
Brain nothing, no.
Your brain working and my brain just it's refusing to work. So let me show you something. The reference angle is always formed between the line and the x-axis. So I'll show you why we're doing this. So if I want to figure out angle in the third quadrant, see if you can remember how to draw the arrow. Show me if you remember how to draw the arrow.
Third quadrant. That'll be like that.
Ooh, you well remember. Hey boy. You make him a pro boy. Okay, okay. All right. And I'm just labeled it. So this is 0 degrees. It's gonna be 90. It's gonna be 180.
180, 270, 360.
So if I wanted to figure out this green angle, that come like you go in 180 degrees, and then you go in an extra 30 degrees,
Yeah. So
Cool.
180 plus
right? 180 plus 30, and that will be
210.
so if I plug the angle into sine, what's supposed to get?
210. I mean 50. No, minus a half.
Right. So try that right now for me. Put sine 210.
Minus a half.
Right. So that's one of my solutions. But I have another solution, and that other solution is where
And then the fourth quadrant.
fourth quadrant, right? So show me how that will look like the arrow.
Yeah. That.
Yeah, boy. All right, nice. And how are you gonna find that then?
It's 270 minus.
No, it wouldn't be 270. This think about it like this. It come like you're stopping to
Oh.
or 360.
Yeah.
So that'll be
360 minus
right. So the angle is
350.
360 degrees. So plug that into the calculator and just confirm that you get an minus a half.
Yep.
Nice. So next thing you need to know for trig, you need to know the trigonometric proofs. Right? I know they love that. So
Yeah.
I will do two trigonometric proofs. I'll give you a 10 minutes break, and then we're gonna do some probability questions. Cool. Ready?
Just finished.
I will go see. We'll see. I'm not sure. We'll see.
For probability, we could do for probability, we could do the two about probability trees.
Sure, no problem. The probability trees. Yeah. So that's some general rules I will tell you all when doing trigonometric proofs. The first rule. So guys, anytime you see tan theta, we're going to convert that to. If you see tan theta, what are you going to convert that to? Come on, we gotta move with speed.
Sine theta.
Sine theta over cos theta. If you have two different denominators, what to do, right? Find LCM. Find your LCM. Right? Next thing I would recommend, you need to know sine squared theta plus cos squared theta is equal to what, Chan? Equal to 1. And if that is the case, sine squared theta will be equal to,
1 minus cos squared theta.
and then cos squared theta will be equal to,
1 minus sin squared theta.
right, cool. And the next thing you need to look out for is difference of two squares. I know this is particularly notorious. But sure, you know what I mean? So let me just say we had 1 minus cos squared theta, right, guys? So anybody can tell me what's another way I could write 1 minus cos squared theta? 1 minus cos squared theta is the same thing as what by what?
Cos theta by cos theta.
Nah, I'm sure you know what I mean. Difference are two squares. Difference are two squares.
Plus,
Comma.
it'll be 1 plus cos theta.
Yeah. So difference are two squares, a squared minus b squared, that is equal to a plus b by a minus b. So another, this come like 1 squared minus cos theta squared, right? And Cheyenne, if that is the case, tell me what 1 minus sine squared theta will be.
1 plus sine theta and 1 minus sine theta.
Right? Another thing you need to know, you need to be able to factor out things. Factorize. Sometimes you might have to factor out the greatest common factor. Sometimes it will be, you might need to factor out, like you might need to factorize quadratics if the proof is particularly tricky. Yeah, but these are the general things, general advice I would recommend when doing that question. And I would recommend always taking the left hand side. But I think everybody knows to do that right now. Take the left hand side. Right, so there we go. All right, yeah. And you also need to know how to you need to know how to convert division to multiplication. So let me give you an example, right? Cheyenne, if I had 1 all over a half, 1 all over a half, that means I divided 1 by what?
2 over, no, a half.
I wanted to convert that to multiplication. I'll write it as 1 multiplied by.
2 over 1.
Right. So let me give you a trickier example. Imagine you had 2 all over 1. That come like what? 1 divided, so that come like 2 divided by
1 plus sine theta over cos theta. You would just write that as 2 by 1 plus sine theta over
nah. When you
cos theta over 1.
when you flip it, you go when you change the sign, you go flip it, and now it will be 2 by what? 2 by cos theta.
2 cos theta over 2 plus 2 sine theta.
Nah. The 2 is on top, so you'll only multiply by what is on top, which is cos theta. In the bottom, you have 1 multiplying by that, so you get back 1 plus sine theta. Let's be wary of that. So let me do this question. So as normal, consider the left hand side, right? I take any left hand side. First things first, what do you notice about the left hand side? Somebody tell me the obvious. Cheyenne, always keen on the left hand side, but we had to change immediately.
Tan theta.
So what?
Sine theta over cos theta.
Right? Do they have the different denominators or the same denominator?
Denominator.
So we could just combine them one time. Right? So combine this one.
Sine theta over cos theta.
No. I'm gonna show you something. If I have 2 over 5 plus 3 over 5, what will be equal to?
5 over 5.
Right? Because you add the 2 to the 3. So over here, you're gonna add the 1 to the sine theta. You understand?
Yeah.
So imagine if you had 1 over 5 plus 2 over 5, that will be equal to
3 over 5.
3 over 5, right? Be careful about that. And now it come like you have 1 divided by 1 plus sine theta over cos theta. And Cheyenne, how I'll convert that to multiply?
1 by cos theta over 1 plus sin theta.
It's a little muffled.
1 by cos theta over 1 plus sin theta.
Right. Right, what is 1 by cos theta?
Cos theta.
All over.
1 plus sin theta.
Now, this is where things get tricky. This is a particularly tricky question for this. Notice that on top you have 1 minus sine theta, and on the bottom you have cos theta. So I will show you all what to do in this situation. In this situation, you're going to multiply by 1 minus sine theta on the top and bottom. Now, to do this question, you must have some kind of foresight. Cheyenne, let me explain why I'm doing this. Probably think I'm a madman. Why I'm doing this. So Cheyenne, on top, it will be cos theta by 1 minus sine theta. And in the bottom, this is an example of what? If you're multiplying 1 plus sine theta by 1 minus sine theta, what we know you will get? That's an example of what? Our D. DI.
And that is
Right? So if I multiply 1 plus sine theta by 1 minus sine theta, what will I end up with?
1 plus sin
Nah,
square theta.
it's not plus, it's minus. You're going to put 1 minus sine square theta. And Cheyenne, what is another way I could write 1 minus sine square theta?
1.
What is 1 minus sine square theta equal to?
Oh, cos square theta.
Right? You see anything that could cancel off?
Cos theta equals square theta.
Right? So we end up with.
Cos theta. 1 minus sin theta over cos theta.
And like I said, this one was a particularly tricky question because you actually had to introduce something new. Yeah.
You know what I would have done if I didn't know that? I would have just flipped it.
You gotta do what?
I would have just flipped it and lose mark.
You can't split that, you know. You can't split that.
No,
If-
not split.
You know what?
I'd have just flipped it and lose mark. If I didn't know what to do.
This is a tricky part. This has happened really, but it's something to keep in mind. You had to multiply by something on top and bottom. It's kind of hard to see. But the reason I multiply by 1 minus sine theta is because I know difference are 2 squares. If I do that, I'll get 1 minus sine squared theta, and I might be able to go somewhere with that. Right? Because Cheyenne, where's 1 minus sine squared theta?
Well, that's not
Where's 1 minus sine squared theta?
cos square theta.
Right, so that is why I multiply by 1 minus sine theta. I just do that. I tell myself I might go somewhere, and it work out. So look out for the difference are 2 squares. And this was the like odd question. So odd question. Let me do one more. Right. Yeah, Sean, where you looking to convert immediately?
Tan theta.
Right. So tan theta is the same thing as sine theta over cos theta. So we have sine theta over cos theta multiplied by sine theta all over 1 minus cos theta. What are you gonna end up with at the top?
Sin square theta over cos square over cos theta.
And I'm gonna show you something. You're gonna convert that division to multiplication. So right now it come like you have sine square theta over cos theta divided by what? Did I get?
Oh, divided by 1 minus cos theta.
if I want to convert that to multiply,
By 1/1 minus cos theta.
yeah. Let me show you how far you're gonna be guided. You have to let the maths take control. So, Cheyenne, in this question, which trig you see any most? Sin any most or cosine most?
Cos.
So lean with our side. Can we convert sine squared theta to cos squared?
Yeah.
Sine squared theta is the same thing as what?
Minus cos squared theta.
Right. And you will see where this leading up to. 1 minus cos squared theta. That is what? It's our D.
Difference of 2 squared.
So how I could write that? 1 minus theta.
1 minus cos squared theta and 1 plus cos squared theta.
Nah, is 1 minus cos theta by 1 plus cos theta. Was close. The only thing that could potentially cancel out.
1 minus cos theta. You get 1 plus cos theta over cos theta.
And is that what we wanted to prove?
Yeah, I think so.
Let me check. And now we nearly there. Nearly there. So you see, now we can split this up. Now we can split it up. So if I split this up, what we're going upwards? All right, just split that up.
1 plus.
So let me show you. If you had 2 over 5, 3 over 5, you can write that as 2 plus 3 over 5. And you could also split it up to 2 over 5 plus 3 over 5. So split this up. Same kind of thing. So this come like 2.
G, we could follow.
Yeah, so Sharon, we had to split up 1 plus cos theta over cos theta. So imagine if you had 2 plus 3 over 5, you could split that up to 2 over 5 plus 3 over 5.
1 over cos theta over cos theta.
Right. And so that'll be 1 over cos theta plus cos theta over cos theta. Cos theta over cos theta as well.
G, I had leave now.
What is it?
I had leave now.
You gotta leave now?
Yeah, you could send you for an after class one so I could watch myself.
No problem, not guys. Right, so thank you for coming meet her. So Cheyenne, where is cos theta over cos theta?
No,
Imagine
I
us
don't know.
5 over 5.
1.
Right, so anything over any, like once any same thing being divided by the same thing is 1. So you end up with 1 plus 1 over cos theta. Yeah. Right, that's it for tricks. Yeah. So take a 10 minutes break and we'll continue with probability. Add a lemma Apple Pencil charge. Take our time, let's break. All right, Cheyenne, let me know if you hear me.
Yeah.
All right, so let me speed through probability. Let me see what we can do. Let me see percent the reach. It's 70, reach 76%. Okay, nice. Um, all right, so let me jump straight into it. So you know how to find probability in general, right? Like let me just say I had 5 years. Let's just say I had 5 girls and I had 2 boys. How much people I have altogether? 7. So how much, what is the probability of picking a girl?
5/7.
What is the probability of picking a boy?
2/7.
Shiny, you're sounding real tired.
I am.
Your brain like it's saturated.
Yes. I'm actually.
You want to try to have class another time to do probability?
Yeah.
Yeah.
Yeah. I don't remember anything from it.
Because if we do anything now, I don't feel like you will absorb anything.
Nope.
So I will try to move or have the class probability some other time. Because I
Yeah.
feel like,
I feel that way.
what is it?
That could be better.
Okay, nice. Because I feel like everybody tired and it's not it. So
Mm-hmm.
Cheyenne, I guess I'll see you Friday, which is tomorrow. I'll see you
Yeah.
tomorrow. All right. Well, it should be better though because we see each other in person. Yeah.
Yeah.
Try to get some sleep and thing. So yeah. Later,
Our
Cheyenne.
next class.
We have our next class.
Bye-bye. Yeah.
Oh good. I'll try to get some rest in between or something.
Yeah.
Later.
Bye.